Welcome to the Mixed Fabric Data Pipeline Masterclass. My name is Aleksi and I will be your teacher in this masterclass, and I will be teaching you how to build data pipelines in Mixed Fabric. After going through this masterclass and doing all the tutorials with me, you are well on your way mastering the data pipeline tool in Mixed Fabric. Before we get started, I would like to give a brief introduction to me and the contents of this masterclass. Let's start with me. I have been working with Microsoft Data Platform Stack for over 5 years now, and currently I'm working for a top-tier Microsoft partner company with headquarters in Finland that provides state-of-the-art data platforms using Microsoft Fabric and Azure Data Platform Stack. In my current role in the company, I work as a solution architect and a team leader for data engineers and architects. My personal day-to-day job still involves quite a lot of data engineering with Microsoft Fabric and Azure, and thus I'm very familiar with data engineering tools in those stacks. One of my favorite tools over the years has been Azure Data Factory, that has been now rebranded to Microsoft Fabric as the data pipeline tool, and this masterclass is all about that tool. And now let's talk a bit about the contents of this masterclass and what kind of topics you will learn in this video. This video is broken down to 20 smaller lessons, and every lesson teaches you a new topic about the data pipeline tool. All of these 20 lessons are older videos that I have already published on my YouTube channel as part of my Microsoft Fabric data engineering series, and combined them to this one pipeline masterclass. It is good to keep in mind that these lessons build on top of the previous lessons, and it is highly recommended to go through these lessons in order. However, if you'd like to skip some lessons or only watch a specific lesson, you can do so easily by using the timestamps that I have added to this video. Now let's go through a brief overview of the lessons we have in this masterclass. Lesson 1 introduces an overview of the data pipeline tool in Microsoft Fabric. This session provides a foundation by explaining the key concepts, ensuring that you are familiar with the basics before diving deeper. In Lesson 2, we will focus on the copy data activity, one of the most essential activities to master. This allows you to transfer data from one source to another, a core function of any data pipeline. Lesson 3 explores data pipeline parameters, a crucial feature that enables passing external values into data pipelines, enhancing flexibility. Moving to Lesson 4, we will cover pipeline variables, which offer additional logic building capabilities within your data pipelines. Lesson 5 introduces expressions and dynamic content, showing you how to create more flexible and dynamic pipelines. In Lesson 6, we will delve into if conditions, which allow for conditional execution logic within your pipelines. Lesson 7 focuses on the for each activity, enabling you to create powerful iterative pipelines. Next, in Lesson 8, we will cover the Lookup Activity, which lets you retrieve data from a file or a data store and utilize that information within your pipeline. In Lesson 9, we will explore the Get Metadata Activity, providing insights into retrieving metadata from files or data stores for use in your pipelines. Lesson 10 covers scheduling and monitoring your data pipelines, ensuring smooth operations and timely execution. In Lesson 11, we will discuss how pipeline return values work, showing you how to pass information from a low-level pipelines to a top-level ones. Lesson 12 dives deeper into pipeline inputs and outputs with a focus on how they can be used to enhance pipeline logic. In Lesson 13, we will introduce the switch activity, adding another layer of conditional logic to your toolbox. Lesson 14 covers data pipeline best practices, offering key considerations to build more production-ready data pipelines. Lesson 15 will help you to master the delete data activity, essential for removing data when necessary. In Lesson 16, we will explore the filter activity, allowing you to filter lists based on specified conditions. Lesson 17 teaches how to copy data to a Fabric data warehouse. In Lesson 18, we will examine stored procedures and how to integrate them into your data pipelines for more complex tasks. Lesson 19 introduces configuration-based pipelines, unlocking powerful new capabilities for more dynamic pipelines. Finally, in Lesson 20, we will expand on the configuration topic by showing you how to use dynamic content in column mappings, adding another layer of versatility to your pipeline development. Many of these lessons will require you to use some files, and all the files that I will be using in the tutorials can be found by clicking the link in the description. But now let's get started with the Lesson 1. But now let's talk about the pipeline tool in Microsoft Fabric that is one of the most essential, if not the most essential tool for data engineers to learn in Microsoft Fabric. With this tool, data engineers can build complex data pipeline workflows and then schedule and monitor them. First, in this video, I will cover the core concepts of the pipeline tool on conceptual level, and then we will hop into Microsoft Fabric and check out the pipeline tool a bit more closely there. But now, let's get started. Let's start with activities. Activities are these nodes in the pipeline that are executed in a logical and predefined order that is defined during the pipeline development process. In Microsoft Fabric pipelines, there are many different activities that serve different purposes and use cases in data engineering. For example, activities could be used to execute other tools in Microsoft Fabric like data flows and notebooks. Or activities could be used to add some conditional logic to the pipeline. For example, run a notebook only when set conditions are met. These activities are not only limited to running things inside Fabric, since these activities extend to external services as well. One of the most used activities is the copy data activity that can move and copy data between two different data stores. The data store could be also outside the Fabric and be an external system from which the copy data copies the data to Fabric data store or vice versa. Also, there are activities for executing external services like Azure Functions and Databricks notebooks. More general activities like REST and webhooks make these integration possibilities very extensive. To be able to fetch data from an external store or run external services like Azure Databricks notebooks requires connections, which takes us to our second key topic, connections. As the name implies, these are connections to external systems and services. For copy data, there are already quite an extensive set of external systems to connect using variety of authentication methods. And Microsoft is constantly adding new connections to choose from and new authentication methods to old connections. Our fourth core concept are parameters that can be defined on multiple levels and allow passing through information to different levels in pipeline tool. In practice, this means that using parameters, information can be passed down from a pipeline to activities, for example, to notebooks, or from a top-level pipeline to a lower-level pipelines. Also, there are variables in pipeline that can be used in a bit similar fashion than parameters. The main difference between parameters and variables is that parameters are used to get information outside the pipeline into the pipeline, and variables on the other hand are defined inside the pipeline and has to be set during the execution using setVariable activity. Pipeline parameters and variables can be referenced in other activities by using pipeline's expression language. This expression language allows adding more logic into pipelines, making them more dynamic. Very simple example of using this expression language would be adding dynamically timestamps to file paths when copying data from an external system to Lakehouse's file section. Since the pipeline is an orchestration tool, it is quite obvious that it can be scheduled to run at set time intervals. This feature enables data engineers to run their pipelines outside of office hours, which moves those heavy data pipeline processing workloads to times that do not bother other users of Fabric. Also, pipelines could be monitored by using monitoring features in Microsoft Fabric. This allows looking at past pipeline runs to see how they went and how long it took to run the pipeline and its different activities. Next, let's open up Microsoft Fabric and let's check out the pipeline tool there. Pipelines in Fabric can be found under Data Engineering and Data Factory experiences. Here we have a possibility to create a new pipeline. Then we have to give a name to our pipeline, and after this we can click OK. This opens up the pipeline development view, where we have the options to start with a blank canvas or with guidance, which means using a copy assistant, practicing with sample data, or pre-made templates for pipelines. For now, we are going to go with a blank canvas, which makes us to choose one activity for our pipeline. Here we can see all the activities that are available in pipelines, but we will come back to this shortly. Now I will just choose a simple wait activity and let's start with that. Now we are in the actual pipeline development canvas. To this canvas, we would start to add other activities and start to build our data pipeline. Before we add other activities, let's check out the tabs in the top bar of this view. Let's start with the Home tab. In this tab, we can find possibilities to save our pipeline, adjust the settings, validate our pipeline, which means checking that everything is configured correctly. Also, in this tab, we can run our pipeline or schedule our pipeline run at given time intervals. By clicking the schedule button, we can define the time interval when we want our pipeline to run. At the time of recording this video, this is the only way how pipeline run can be triggered, but according to Microsoft, new triggers will be added in near future that would allow running pipelines based on an event like file creation. Next, in this bar, we have the possibility to view run history for this pipeline. That is empty for now, since this is a completely new pipeline. After that, we have few very commonly used activities that we are going to come back to very shortly. Under the Run tab, we can find the same buttons that we already had in the Home tab. In the View tab, we have some features to align and fit our pipeline to our development canvas. Also, we have the possibility to view JSON code for our pipeline, since on the background our pipeline is defined as JSON, and this is the way how you would see the pipeline objects in version control like Git if you are using that. Directly modifying this JSON could be tricky, but it allows you to do very efficient bulk change operation to your pipelines if you know what you're doing. Now let's open up the most juicy tab, which is of course the Activity tab. In this tab we can find all our activities that we can add to the pipeline. We are not going to go through all of these activities in this video, since we are going to have a dedicated videos for the most important and used activities. Now let's just do a quick overview of these activities. We can see that we have some other Fabric tools like data flows and notebooks as activities here. This means that we can run those tools as part of our data pipeline logic. Also, we have some control activities like if conditions, loops, and so on available here that would allow us to add an extra layer of logic to our pipelines. Some of you might recognize a Databricks icon here, which means that we can run Databricks notebooks as part of our pipelines as well. Under these three dots, we can find a bunch of more activities. For now, we only have a wait activity in our pipeline that would just wait a set amount of seconds before completing. Now let's drop another activity to the canvas and let's see how we can chain these activities together to form a logical flow to our pipeline. Let's drop in a copy data activity that would copy data from some source to some destination. And now we have two activities on our canvas, and by hovering our mouse over these activities, we can see these small icons appear on the right side of the activity. These can be used to logically build dependencies between activities. The default way is using the onSuccess dependency, which means that the following activity or activities are executed once the previous activity has been successfully executed as well. There are also other dependencies that can be used, like for example executing activities if the previous activity failed. But now we can link these two activities together by using the onSuccess dependency. Now let's take a look at the copy data activity a bit more closely. When we click this activity, we can see the tabs under our canvas change. We are not going to dive deeply into these different tabs in this video, but let's open up the Source tab. As a default, our copy activity uses Fabric workspace data stores like lakehouses, data warehouses, or KQL databases. Now let's change this data store type to external, and here we can see that now we would have to define a connection that we talked about earlier, since we would be using an external data store. Under this connection selection, we can see a few connections that I have already made to this workspace, but now let's click to the New button and define a new connection. Here we can see the list of connections that are currently available in Fabric. By using this connection feature, we would be able to create connections to these systems and data stores and would be able to read or write data to those systems or data stores. But for now, let's not create any new connections here. If we click somewhere to the blank area of the canvas, this would show us some different tabs under the canvas. Here we can find the parameter tab that would allow us to create parameters for our pipeline. We can see that we have many different data types available for our parameters. Next to our parameters tab, we have the variable tab, and here we could define new variables to our pipeline, and also for those we have few different data types to choose from. Next, I will briefly go through the basics of dynamic content and expression language in pipelines. Let's, for example, open our wait activity and navigate to the Settings tab. Here we can see that our wait time has this hard-coded value of 1. And here we could change that hard-coded value to something else. But with dynamic content, we could add some logic that would decide the wait time value. If we click this input field as active, we can see this add dynamic content appear under this field. By clicking it, we can open up the pipeline expression builder. That would allow us to use parameters, variables, and functions in defining the value for the wait time. However, for now, we are not going to start build any expressions, and we will come back to this dynamic content multiple times during this video series. Next, let's check out the monitoring hub where we could monitor our pipeline runs. Monitoring hub can be found here in the sidebar, and clicking it will open up the monitor hub view. Here we could actually see runs for some other Fabric items that can be scheduled, like notebooks and data flows. But now let's focus only on pipelines and only show them by filtering them to this view. Here I have some example runs of a pipeline that I created. We can see that this pipeline has been running successfully, and by clicking one of these runs, we can observe a lot more closely what happened during the execution of the pipeline and how long it took to execute each activity and what those activities did and so on. But now let's cover the copy data activity in the pipeline tool. Here on the screen we can see how copy data activity looks in the pipeline UI. Let's first talk about the purpose of the copy data activity, which is, as the name implies, copy data from place A to B. In the context of copy data activity, place A is called source and place B is called destination. Let's dive a bit deeper into these sources and destinations in copy data activity. With copy data activity, data engineers can move data between two data stores. These data stores could be Fabric data stores like data warehouses, lakehouses, or KQL databases. Or they could be some external data stores and systems from which the data is copied from or copied to. This makes copy data an excellent data integration tool for many different scenarios. Copy data activity can copy data in binary format, which means that it can move data without caring what type of data it contains. So this means that copy data can basically copy all types of data when using binary copy setting, since it treats those files as binary blocks without reading the actual data inside the file. You can think of these cases like copying just some files on your local computer from one folder to another. And of course there's a possibility to copy those files and leave the original files to the source, or delete the source files after the copy has been executed successfully. Also, when copying files, a file format can be specified, which then opens up more options in the copy data activity. For files, copy data supports using many of the most common text-based file types like CSVs, or more correctly said, delimited text files, and JSON and XML files. Also, some more advanced file types are supported as well, like Parquet, Org, Avro, and even Excel files. For destination side, some of the same file types are supported, but now the selection is narrowed a bit, since copy data does not support writing data to some file types that are available in the source side, like XML and Excel files. Also, when we expand our sources and destinations from files to Fabric's data stores and external systems and data stores, we get even more possibilities to use the copy data activity. As you can probably guess, the copy data activity can transform the data format when copying the data. For example, copy data from on-premises SQL Server table to Delta table in Fabric's Lakehouse, or vice versa. Basically, you are able to mix and match these sources and destinations however you like and is needed for your purposes. Even though copy data is not really a data transformation tool, and there are way better tools in Fabric for that purpose like data flows and notebooks, it still has some limited data transformation capabilities. Like discussed, copy data allows you to change the data format, for example, from a flat file to a Delta table. Also, copy data allows you to change column names and data types by using the mapping feature. Now let's hop into Fabric and let's do two tutorials using copy data activity. Before we start to build our pipeline, let's check out our lakehouse first, where I have created two folders under the file section called Fabric DE Series 4 Source and Destination. In the source folder, I have one file called movies.csv. We can preview the file contents by clicking this file and see that there is a header and 3 rows that contain data. Our destination folder is empty, and now we would like to copy this file to our destination folder using copy data activity in pipelines. Next, let's hit the create button on the sidebar and create a new data pipeline. Then we have to give a name to our pipeline using our naming conventions. This then loads up the pipeline development view. Here we want to continue by adding one pipeline activity to our pipeline that will be copy data activity. Now we have our actual pipeline development canvas open and we can start to configure our copy data activity. First, let's name our copy data activity to copy data movies binary. After this, we can start to configure our source tab. We want to use our workspace data stores, and then we want our data store type to be lakehouse. Then we have to find our desired lakehouse from the list of available lakehouses in our workspace. Next, we want to change our root folder to be files, since now we are copying files from one folder to another. Then we can click this Browse button and navigate to our source folder and select our movies.csv file there and then click OK. Then we can leave file format as binary, since now we want to move this file as binary block and not care about the file contents during this first tutorial. Under the advanced settings, we have few more settings that we could use. The most important of these settings is to delete files after completion. If we would tap this setting, the file would be deleted after the copy has run, but for now we don't want to delete the original source file. Next, we can proceed to configure the destination for our copy data activity. We want again to use our workspace data store and use lakehouse as the data store type, and then select our desired lakehouse from the list of lakehouses in our workspace. Then let's select files as our root folder, and next we can use the browse to select our destination folder. Since our destination folder is empty and there are no files to choose from, we can just click OK after clicking our destination folder. Then to the file name field, we can type the file name that we want to use for our copied file. I'll write here movies_copied.csv. And again, we want to use binary as our file format. Also for destination, we have some advanced settings that are irrelevant for this tutorial, but here we could do some optimizations for our copy activity and add some metadata to the copied files. But now we should be done with our configuration and we can try to run this pipeline and see what happens. Let's first click the validate button to see that we have configured everything correctly. It seems that everything is okay from the configuration perspective. Next, we can try to run our pipeline, which will then ask us to save our pipeline before we run it, and then we can click this save and run button to do that. This will save our pipeline and trigger a pipeline run for this pipeline. Here in the output tab, we can see that our pipeline ran fine. By clicking our activity name in the output, we can get more information about the run, and we can see that one file was read and one file was written, which was the purpose of this exercise. Next, we can navigate back to our lakehouse and check out that we have that movies file in our destination folder. And here we have it, so everything went as we wanted and configured. Next, let's do another tutorial, but now I would like to copy the contents of the movies.csv file to a table in our lakehouse. We can see that we don't have any tables in our lakehouse yet, but we can actually use the copy data activity to create that table for us when we copy data there. Now let's create a new pipeline and again name that pipeline according to our naming conventions. Also, this time we want to just add a copy data activity to this pipeline. Let's name our copy data activity to something that describes what's happening, like copy data movies CSV to LH table. Then we have to start from our source tab and choose our lakehouse to be the source for our copy. Again, we want to use the Lakehouse file section and then navigate to our file. The first thing that we are going to do differently this time is to change the file format to delimited text. Then we could click the settings button next to the format to configure our delimited text settings. Here we could change things like row and column delimiters and encodings and so on. But for now, I know that my files follows these default settings, so we can leave them as default. Because we are now reading the contents of the file, we have this preview button available next to our file path and we can click that. This then loads a preview of the file and shows that how the data would look in a table format when using the settings that we have defined for delimited text. Here we can see that the data looks good, so we are done with our source configuration. Now we can move to the destination configuration. Here again, we will select our Lakehouse to be the destination for our copy. However, now we are going to use the tables as the root folder and then write the table name here that we want data to be copied into. I'm going to name our table just as movies. Under the advanced section, we can choose if we want our copy data to append the data to the table or just overwrite it with a new data. Since we don't have a table there yet, there is no need to append the data and we can just select the overwrite option. Now we are done with our destination configuration. Next, let's open the mapping section where we can do some light data transformation. Here we can click import schemas that will import our columns from our source and destination, so we are able to do some changes if we want. Since we are using CSV data that doesn't have any data types, all our columns are now strings and they are going to delta table to string columns that have also a string data type. Here we could rename our columns for our destination. That we are not going to do now, but if you remember, our rating column is actually a decimal column, and we could change the type for that to some numeric type that has decimals like decimal, double or float. Let's just use float for now without diving deeper into differences between these data types. Now we are done with our configuration and we can click validate button to see that everything is configured correctly. And after that we can click run and that will save our pipeline. Now we have to wait for our pipeline to run and then we can observe what happened and did everything went as planned. Now our copy data has done its things and we can click the activity name in the output to see more information. Now we can see that 1 file and 3 rows were read from the source and 1 file and 3 rows were written to the destination, which seems to be correct. Next, let's open the Lakehouse and navigate to the table section where we can see our movies table. By clicking the table, we can open up the table data preview that will take a moment to load up. There we can see that our data looks good in our table, so everything went as planned. But now let's talk about pipeline parameters that are one of the key features in Microsoft Fabric pipelines that allow data engineers to build more dynamic and flexible pipelines that will save up development time and reduce the overall complexity of those solutions. In this video, I will first cover the pipeline parameters on conceptual level that will help you to understand how they work. And then we are going to have a demo/tutorial that will show to you how these parameters work in action. Let's get started. Let's imagine a situation that we have a lakehouse in Fabric, and in that lakehouse we have 2 files, f1 source.txt and f2 source.txt, and then we would like to copy these files to another lakehouse and change the src in the file name to dst. How could we get this done? Of course, there are multiple ways to achieve this goal in Fabric, but one simple way would be use Fabric pipelines. We would create a Fabric pipeline and add 2 copy activities to that pipeline and then copy those files from our source lakehouse to our destination lakehouse. This setup is all good and fine and it works, but we can use it as an example to demonstrate how we can use pipeline parameters to reduce the number of activities in this pipeline. We can start by removing these 2 copy activities and replacing them with just 1 copy activity. Next, we would like to add 2 parameters with a string data type to this pipeline called source file and destination file. Then we can pass down these parameters from the pipeline level to copy activity and use these parameter values to dynamically decide which file to copy. For example, when running the pipeline, if we would add string f1 source.txt to source file parameter and f1 dst.txt to destination file, we would be able to copy f1 source file from our source lakehouse to our destination lakehouse with a different name. And by running this same pipeline again and changing the parameter values, we would be able to copy the other file as well without doing any modification to pipeline itself. This is just a simple illustration how you can use parameters in pipelines to do things dynamically. Next, let's go through a few key points about parameters. The main functionality of parameters is passing external values to pipelines. Parameters can be literal, meaning some hard-coded values, or parameters can be expressions that are evaluated when the pipeline runs. In this video, we are not going to cover expressions since we are going to have a dedicated video on them during upcoming weeks. But it is still good to keep in mind that you don't have to use some hard-coded values when using parameters. Parameters can be very helpful and save a lot of development time when used correctly, since they allow adding dynamic logic and they can be used in all the places that support adding dynamic content that I'm going to demonstrate you shortly when we open up Fabric. Also, as a last takeaway here, it is good to note that there are different data types available for parameters that are string, integer, float, boolean, array, object, and secure string. Now let's hop into Fabric and let's do a demo/tutorial that will help you to learn and see how these parameters work in action. Let's start by opening up a lakehouse to which I have already created two folders for this tutorial. We have Fabric DE Series 5 source and destination folders. Our destination folder is still empty, but in the source folder I have two files that I have uploaded there. The goal of this tutorial is to copy these files to the destination folder and change the file name by using pipeline that uses parameters to decide which file to copy. Next, let's click Create and select a new data pipeline and name that pipeline according to our naming conventions. Then we wait for the pipeline development canvas to load up. Next, we want to start building our pipeline using blank canvas and just add a copy data activity to that canvas. We can name this copy activity to reflect what it does, and since the goal was to copy data from lakehouse to lakehouse, we can name this copy data from LH to LH. Then we can click somewhere to the blank canvas so that the tabs under our canvas change. Here we can find the parameters tab that we are going to use in this tutorial. We want to create two parameters for our pipeline that are both going to be string type. Next, we can name our first parameter to be source file name and then our second parameter to be destination file name. We could add some default values for these parameters that would be used if these parameters were not given any values when running the pipeline. But there is no need to do that in this tutorial. Next, we can open the copy activity and configure our source tab. We want to use the lakehouse that I showed you previously as our source, so let's select it from our list of lakehouses. Then we want to use files as our root folder since we are copying raw files. Next, we can click Browse and select our source folder. However, even though we can see both files in our folder, we don't want to select either of those since we don't want to hardcode the file names to our file paths, so we can just click OK without selecting any files, and this will then just add our folder to our path. Next, let's click the file name field as active, and this will then show this Add Dynamic Content under the input field. Let's click it. This will then open the pipeline expression builder that we are not going to cover in very detail in this video, but we can see that in parameter tab we have two parameters available, and those are the same parameters that we defined to this pipeline previously. Since we are now configuring our source, we want to click the source file name parameter that will then automatically create the expression for us that will point to that parameter. Next, let's click OK, and we can see that now we have that parameter expression in our file path after our source folder. We can just quickly check that we are using binary as our file format, since in this tutorial we are copying files as binary blocks without caring about the file contents. Now we are done with our source configuration. Next, we are going to configure our destination that will happen in very similar fashion. We want our data store to be workspace data store and the type to be lakehouse. Next, we want to find our lakehouse from the list of lakehouses. Then we want to change our root folder to files and again browse and find our destination folder. And again, not to select any files that are not found in any case since our destination folder is empty. Then for our file name, we want to use dynamic content and now select our destination file name parameter and then click OK. File format is already binary like it should be, so now we have configured our destination correctly. Then we can click and validate to see that there are no configuration errors in our pipeline, and there were none, so everything should be fine from configuration perspective. So the next step is to run our pipeline. We can click run, that will then prompt us to save and run this pipeline, and we can do that. This will then ask us to provide values for our parameters that we have defined for this pipeline. To the first parameter, we can now input the file name of our first file, that is f1 source.txt, and to the destination, we can input the name that we want that file to have after it has been copied. And I'm just going to change src to dst in the file name. Now we can click OK. That will then trigger our run. Now we have to wait for our run to finish. Now our run has finished and we can click the activity name to get a bit more information what happened there. And we can see that one file was read and one file was written, so that seems to be correct. Also, before checking the lakehouse, I want to show to you two tips that might help you when you're working with parameters. My first tip is to show to you how you can double check which parameter values were used when running the pipeline. This can be done by clicking this little @ sign here, which will then show the parameter used for the run. The second tip is that we can check activity input to see what was the value that went to our file name when the pipeline ran. This can be done by clicking this input icon here and browsing this input JSON. Here we want to find the value for our file name property, which is the parameter value that we gave to this pipeline. Next, we can go and check out our lakehouse and see that we have a new file in our destination folder. So according to this, everything went as planned. Let's go back to our pipeline and now run this pipeline with different parameters and copy our second file to our destination folder as well, with the same convention as the previous file. Now our run has succeeded and let's go to our lakehouse, and as we can see, now we have two files in our destination folder. But now, without further ado, let's start covering pipeline variables. I will first go through a few key points about pipeline variables, and then we are going to open up Fabric and do a quick demo/tutorial to demonstrate to you how these variables work in action. Let's get started. Pipeline variables are values that are defined during the pipeline execution and live inside the pipeline, which is the key difference when comparing them to parameters that we covered in the previous video. Since parameters are values that are given to the pipeline and come outside of the pipeline to the pipeline itself. The main purpose of variables is to add some extra logic to the pipeline and to hold some intermediate data for processing purposes. Like parameters, variables also support using default values, and if the variables are not set using the set variable activity, then the default value is being used as the value for that variable. Variables also support few different data types. However, when compared to parameters, there are fewer choices. Currently, variables support 4 different data types, which are string for text values, integer for whole numbers, boolean for true or false values, and then array for list of items that could be any data type. The main activities used to interact with variables are the set variable and the append variable activity. With the set variable activity, variables can be assigned some hard-coded or dynamic values using expressions. The append variable activity is meant for adding some new items to the end of array type variables. There are also many system variables that are already predefined and hold some system-related information like the pipeline name, pipeline trigger time, or workspace ID, just to name a few so that you get an idea what are those system variables. Now let's hop into Fabric and let's do a quick demo/tutorial that will show to you how these variables work in action. Now we have the Fabric open. Let's open up the Data Factory experience and then let's create a new data pipeline for our demo/tutorial. I will name this pipeline according to my naming conventions, and then I want to start with a blank canvas and add one activity to this pipeline. The activity that I want to add is the set variable activity, since that is one of the activities that we are going to use today. Now we have our pipeline development canvas open and we are ready to start build our pipeline. Next we want to click somewhere to the blank canvas so that we can see the variable tab underneath our canvas. Let's open the variable tab where we can define new variables to our pipeline. Let's start by defining one new variable to our pipeline. We can name this variable to be var string1. Next, we can choose the data type for our variable. As we can see, we have those 4 options available that we covered in the previous section of this video. For this variable, we can just go with the default string type since we want to add some text here. We can also add some default value for our variable, and let's just write some random text to this field. However, we are going to override this default value using the set variable activity. Let's open our set variable activity and let's rename this activity to keep things nice and organized here. We can name this activity to set variable var string1. Then we want to open the settings tab of this activity. Here we could choose the variable type that we are setting, and there are 2 options. Pipeline variable, that is referring to these regular variables that we are covering in this video, and then we have pipeline return value that is out of the scope for this episode. But very briefly explained, this return value is something that pipeline would return back to an upper level pipeline if we would run this pipeline as part of some other pipeline. Next, we can select the variable name that we are setting here, and since we have defined only one variable to this pipeline, we have only one option in our list and we can choose that. This will then show the value field where we can write the value that we are going to assign to our variable. That will then overwrite the default value that we defined. For now, we can just write a string new value to the value field. Then we can run our pipeline and see what happens. Let's click run. That will then run and save our pipeline. This run should finish very fast since we are just assigning a value to a variable. And now it is already done, and by clicking the activity output we can see that now we have defined a new value for our variable. Next, let's create another variable to our pipeline called var string2, and also this time let's have it a string and not define any default values for it. Then we want to add another set variable activity and name it accordingly. Let's open the settings tab and select our new variable from the list. However, now we are not going to assign hard-coded values for this pipeline, and we are going to use one of the system variables to assign a value for this variable. Let's click the value field so that the dynamic content appears underneath the field, and then let's click that to open the pipeline expression builder. Here in the expression builder, we have the tab system variables, where we can find all the system variables that we have available in the pipeline. We are not going to go through all of them, but some of these could be very useful for logging things or adding some extra logic like fetching files that have been modified before the pipeline was triggered and so on. For now, we are going to select the pipeline name system variable that we are going to assign to our variable. Clicking it will create the expression for using that variable to our expression builder. Then we can click OK. Now we can again run our pipeline and see what happens. Again, our pipeline succeeds very quickly since we are only assigning values to variables. Now we can click the output of our second set variable activity and see that the name of our pipeline was assigned to that variable. Next, let's create 2 more variables to our pipeline that are going to be array type variables. Let's name these var array 1 and 2. Also, let's change the data types to array. For the var array 1, we want to assign a default value, and let's create an array that has two string items, A and B. We could use the set variable activity to set value for our first array variable, but for now we are going to go with the default value and just append a new item to our array. For this, we can use the append variable activity that is meant for this purpose. Let's add append variable activity to our pipeline and let's name it better. Then we can open the settings tab and select the array type variable that we want to add some items to, and we can select our first array type variable. To the value field, we can just write letter C, so that after this activity runs, it will add letter C to our array, which will then have letters A, B, and C, since A and B were already defined as default. Now you could be wondering, what are we going to do with our second array variable? Actually, we are going to assign the value of our first array to it, so we could see what is the value of it after we run the append variable activity. So let's add yet another set variable activity to our pipeline, and let's name it better to reflect what it does. Then we open the settings tab and select the second array variable. And to the value field, we want to use dynamic content and open the variable tab where we can find all our pipeline variables. Out of these, we want to select our first array variable that will be then assigned as value for our second array variable. Then we can click OK. Now we are ready to run our pipeline and see what happens. Again, run should be done almost instantly, and it was. Then we can check out the outputs of our activities, and we can see that our append variable doesn't have an output value. I really don't know why this is, and is this a bug or feature, but let's not care about that too much, and we can use our third set variable activity output to see what was the final value for our first array variable, since we assigned it into our second array variable. Here we can see that we have that letter C also in our list. Also, if it's not obvious, the value for our var array2 variable has that letter C there only because this set variable activity is executed after our append variable activity in the logical flow of our pipeline defined by these green dependencies. If we would swap these activities other way around, our second array variable would only contain letter A and B. That is the default value for our first array variable, and the letter C is only added to the array after our second array was set in that case. But now let's talk about pipeline expressions. That is a very powerful feature in Microsoft Fabric pipelines that will allow you to build some dynamic logic into your pipelines. Learning to use these pipeline expressions is not difficult, but it would be highly beneficial if you have some programming experience or you are at least comfortable using some basic functions in Excel. First, in this video, I will cover on conceptual level how expressions and functions work in Microsoft Fabric pipelines. Then we will hop into Fabric and do a demo/tutorial together to demonstrate how they work in action. But now, let's get started. Let's first cover a few key points about expressions. Firstly, expressions are used for adding dynamic logic to the pipelines in Microsoft Fabric, and they are particularly useful for generating file paths, setting parameter values, and customizing outputs. They can be also used to validate data and handle errors dynamically. Expressions in pipelines start with @sign and are most commonly used using the expression builder that we have already used in the previous episode in this series when we covered pipeline parameters and variables. Also, expressions can be added to string values, but then the syntax is a bit different since the expressions have to start with the @sign and then the expression itself has to be wrapped to curly brackets. Functions are a very important part of expressions, and usually expressions consist of one or more functions that add extra logic to the expression. Next, let's cover a few different types of functions that are available when using expressions. First, we have string functions that are meant for manipulating text values. These functions can be used to format, combine, or alter string data in various ways. One good example of a basic string function is the concat function that is meant for combining text pieces together. Another example of a string function is the replace function that could be used to replace part of a text value with some other text value. Next, we have date functions that are useful for generating datetime related logic to the pipelines. These functions could be used to format, extract, and compute dates and times. One of the most used date functions is the UTC-now function that returns the current UTC timestamp as string value. Then we have other date functions like addDays that is meant for adding days to a datetime value. Third, we have logical functions that allow adding some Boolean, meaning true or false logic to the pipeline. Example of a logical functions are your basic logical operators like and, or, equals, greater, and so on. Then we have math functions that allow performing arithmetic calculations and mathematical operations. Some examples of these functions are add, subtract, multiply, round, max, and min functions that are quite self-explanatory what they do if you have done some basic math studies. Next, we have collection functions that are meant for manipulating arrays and objects. These functions are essential for handling complex data structures within pipelines. One example of these functions is the union functions that can combine two arrays together. Another example could be the empty function that returns true if an array or object is empty and false if it's not. Lastly, we have conversion functions that allow converting values from one data type to another. One of the most basic of these functions is the string function that turns values that are given to it as strings. Then we have a bit more complex functions like the XML function that allows converting JSON objects into XML. Next, let's cover a few very useful examples of function usage in pipelines. Let's start with concat function that is one of the string functions and is meant for combining two or more strings together. Syntax for this function is concat, then opening bracket, and then text values in single quotes separated by commas and then closing bracket. This function requires two or more strings as parameters, and then the return value or output of the function is a combined string from those parameter strings. Now let's go through a quick example how this function works. Let's start with three input strings that I want to give to our concat function. Our first is file, and our second string is _1, and then our third string is .txt. Then we want to give these input string as parameters for our concat function and wrap them in the single quotes and separate by commas. Also, it is good to remember that the expression begins with @. I have also done some color coding here that it would be easier to break down the expression into its different parts. After this function executes, we get our return value or output that is just these three strings combined together. Next, let's go through one very commonly used date function, which is the UTC-now function. This function returns the current timestamp and it can take one parameter as input, but this parameter is optional and it can be used to format the output timestamp if developer so desires. The default timestamp returned by the function when format is not specified is this ISO standard timestamp. Also, good thing to note is that pipelines do not have date or datetime data types when talking about expressions and dynamic content, so that is why the output has a string data type. Again, let's do a quick example to show how this function works. The syntax for this function is very easy if we don't provide any formats as parameters, since it is an optional thing to do. When running this function without any formats, we get that timestamp in that default ISO standard format. Now let's do another example, but now let's provide format for the UTC now function. This format is given to the function in string notation, so using single quotes and then representing different components of the time using this notation seen on the screen, where year is represented using 4 lowercase y letters and month using 2 capital M letters, and so on. After running this function, our output is a timestamp that follows the format that we gave it as parameter. And from my color coding you can see how these numbers map to the format that I used as an example here. Now let's do one more example where we combine these two functions together. We're going to use concat function as our main function, but with a little twist, since our first input string is going to be file underscore, but our second input string is not going to be a regular string, and we are going to use UTC now function with format as our second input parameter. Then our third parameter is going to be .txt. Here we can see how we would create the expression using these two functions together. Also, if it's not obvious, the execution order for these nested functions is always from inside out, meaning that when the function runs, the UTC now resolves first, and then the output of that function is used as a second input parameter for our concat function. Here we can see how does the return value or the output look when we would run this expression. Now let's hop into Fabric and let's do a quick demo/tutorial together to demonstrate to you how expressions and functions work in action. First, let's check out our lakehouse where I have created two new folders, Fabric DE Series 7 source and destination. In our source folder we have one file named file_1.txt, but our destination folder is still empty. Now we would like to copy this file to our destination folder and add current timestamp to the file name during our copy. Of course, we are going to use the pipeline to do this. Let's hit create and create a new data pipeline and name it accordingly. Then we want to start with a blank canvas and add one activity to our pipeline. This time we are only going to need a copy data activity, and we can just select it from the activity list. First, we can name our activity better, and let's name it as copy data from LH to LH. Then we want to configure our source. We want to use workspace data store, and the data store type is going to be lakehouse. Then we can find our lakehouse from the list of lakehouses. Then let's change the root folder to files, since we are copying a file from one folder to another. Then we want to browse and find our file that is resting in our source folder. Usually loading up a folder could take a little moment, and now we can see our file and we can select it and then click OK. Then we can see that now our file path is pointing to that file. To the other settings we don't need to touch, and we can just check that our file format is binary. That should be the default format, since we just want to copy this file as a binary block without caring about the contents inside the file. Next, let's configure our destination in quite similar fashion and select the same lakehouse as our destination and choose files as our root folder. Then we want to browse and find our destination folder. And since our destination folder doesn't have any files, we can just wait it to load up, and then we can just click OK without selecting anything. That will then add only our folder to our file path. Of course, if you are not lazy like I am, you could just type the folder name to this path. Our file name should be still empty, and now we can add some dynamic content there by clicking that field as active and then clicking add dynamic content text that appears under the field. To this field we want to create the expression that will add timestamp to our file name when copying it from our source to our destination. For this we are going to need concat and UTC now functions. Let's start by adding our concat function to the expression builder by finding it from our function list under the string functions. Then we need to provide parameters for our concat function. As a first parameter, we want to add file underscore 1 underscore. Our second parameter is going to be the timestamp, and for that we are going to use the UTC now function that we also covered earlier. It can be found under the date functions. As you probably remember, we could specify a format for our UTC now function, but in this case we are going to go with the default output, so we are not going to give it any formats. Then our last parameter for our concat function, we are going to add .txt. And now the expression should be done and we can click OK. Let's click run and then save and run. That will then trigger the run that will take a little while. But with YouTube magic we can save a little bit of time here. And now our run has completed and we can go and check out our Lakehouse destination folder and see that we have a file there that has a timestamp in the name. So this pipeline worked as planned. If we would run this pipeline again, we would get a new file to our destination with a different timestamp. But this is something that you can try to do by yourself. Also, you could try to add a parameter to your pipeline and then pass down that parameter value to the destination file name and see how that works. But now let's talk about the if condition activity in Microsoft Fabric data pipelines. That is a very essential activity to learn since it allows you to build some conditional logic to your pipelines. In this video, I will first cover on conceptual level how the if condition activity works, and then we will have a demo/tutorial and check out how it works in action. But now, let's get started. First, we can imagine a situation where we have a data pipeline in Microsoft Fabric. In that pipeline, we have one activity followed by another activity. However, after our second activity, our pipeline's logical flow splits. And then we have two more activities, activity 3 and activity 4. We don't want these activities to run at the same time, and we would like to run the activity 3 on Sundays and the activity 4 every other day than Sundays. How could we achieve this in a data pipeline? Of course, we can wrap these activities to an if condition, and that has a logic to run the activity 3 on Sundays and run the activity 4 every other day than Sundays. We will come back to this example in just a moment, but before that, let's digest how if conditions work in a bit more detail. Here we can see how does the if condition activity look in the data pipeline UI. First, for the if condition, we have to define a condition expression using the pipeline's expression language that we have covered in the previous video. The only limitation for this expression is that the output of the expression has to be a Boolean value, meaning that it has to resolve to true or false. Next, we have the two branches in our if condition. There is a one branch for true value and one branch for the false value. And based on our expression that resolves to true or false, the data pipeline will decide which branch to use. Inside of those branches, we can then add actions/activities that we want to perform. When our if condition executes, first our expression is evaluated whether it is true or false. If it's true, then our if condition will execute all the activities in the true branch, and if it's false, then it will execute activities in the false branch. Next, let's cover in more detail how this expression evaluation works and how it is decided which branch to use. Our pipeline logic for this imaginary situation is that on every Sunday we want to fetch all the 30 tables from the source, otherwise we will just copy the 5 tables that are needed daily. Our run schedule for this pipeline is every day at 5 AM UTC time. Then we have our if condition, and in the if condition we have our two branches. In our true branch we have the logic to copy all the 30 tables from the source, and then in our false branch we have the logic to copy only those 5 tables that are needed daily. Now we would need to build an expression that would evaluate the true when it's Sunday and false when it's not Sunday. Here we have the expression that would handle this logic for us. Basically, we would need to have 3 functions in our expression. The innermost function we have is the UTC now function that will resolve to the current timestamp in the UTC time. Then we have wrapped that function to the day of the week function that will take the timestamp from our UTC now function and return a number from 0 to 6 based on which day of the week it is based on our timestamp. 0 means that it's Sunday, 1 means Monday, and 2 means Tuesday, and so on. Then the outermost function we have is the equals function that will then compare the results of our day of the week function to a 0 and then evaluate to true or false based on the outcome of our day of the week function. But now let's again do an imaginary run for our pipeline for June 2nd, 2024, which happens to be Sunday. And let's see how our expression would resolve step by step in this situation. First, when we would run our expression, the UTC now would resolve the current timestamp since it is the innermost function in our expression. Second, our day of the week function resolves using the timestamp that came from our UTC now function, and since our pipeline is running on Sunday, it will resolve to 0. Then lastly, our equals function compares does 0 equals 0, and it does, so it will then resolve to true. This means that our if condition will then run the activities in our true branch, and in this context of this example, copy those 30 tables from the source. Next, let's run this same pipeline again, but now it is running on the following day, which is June 3rd, 2024. This then means that now our expression will resolve to false, since our day of the week will return 1 for Monday, and our equals will then compare 0 to 1, which is obviously not true, meaning false. This will then guide our execution logic to our false branch, which will then copy only those 5 tables from the source. Now let's hop into Fabric and let's do a quick demo/tutorial together so you can see how does the if condition works in action. Let's start by opening up the Data Factory experience and creating a new data pipeline and then naming that pipeline according to our naming conventions. Then we want to start with a blank canvas and then just add if condition to our pipeline. So let's select it from the list of available activities. First, let's inspect our if condition a bit more closely. When we have our if condition selected, we can see these 2 tabs under our development canvas. In the general tab, we have the basic activity general information like the name and description. Then in the activities tab, we have the expression field to which we would like to define the expression logic that has to evaluate to Boolean, meaning true or false. Under that, we have these 2 cases or branches, true and false. And we can see that we have no activities currently in those branches. By clicking this pencil icon in the right side, we could start to add activities to that branch. We would be also able to add these activities by clicking these small pencil icons in the if condition activity or clicking those plus icons in the activity. All of these 3 ways will achieve the same goal. Let's now click this small pencil in the true branch of the if condition. This will then open this blank looking canvas, and from the breadcrumbs on the top left we can see that now we are inside of the true branch, and now we could start to add a bunch of different activities here that we want to run when our if condition evaluates to true. For now, let's just add one wait activity here and name it to true. Then we can go back to the main canvas, and now we can see that wait activity in our true branch. Next, let's add a wait activity to our false branch as well, and let's name it as false, and go back to the main canvas of the pipeline. Next, we would like to define an expression for our condition. Let's open the Activities tab and then click our expression field as active so that add dynamic content will appear under it, and then we can click it to open the pipeline expression builder. Then we want to navigate to functions and open up the logical functions. Basically here we have a bunch of functions that will all evaluate to true or false when ran. Exception being here the if function that we can ignore for now. As an example here, we can use the equals function that we used in the concept section of this video, so let's add that to our expression by clicking it. Now we would have to add arguments/values for our equals function, so that it can compare are they same or not. We could use numbers or strings here. Let's just add string ABC in single quotes as our first value, and then exactly same ABC in single quotes as our second value. Also remember that those values have to be separated by commas. A little tip for you when using these functions here is to hover your mouse over the function you are planning to use so you can get this small documentation about the function and its usage. But for now we have configured our expression, and since ABC equals to ABC, this function should evaluate to true. Now we can click OK and try to run this pipeline. Let's click run and then save and run. That will then trigger a run for our pipeline. That should finish very fast since we are just running an if condition and some wait activities. Now our pipeline run is done, and we can see that we just executed the wait activity in our true branch, since our equals functions evaluated to true. Next, let's go back to our expression and let's use another function and try to get the value to evaluate to false this time. We can, for example, use the less function, and let's hover our mouse on top of it, and the text here says that returns true if the first argument is less than the second. So we have to input a larger number to the first argument to get it to evaluate as false. Let's click the less function and add 2 as our first argument and then 1 as our second argument. Now our expression should evaluate to false, so let's try to run our pipeline and see if it works like expected. Now our run has completed, and we can see that now we ran the wait activity in our false branch. So everything went as we expected. Next, I want to tell you a small but a significant limitation with the if activity that could be a bit annoying when building data pipelines. Let's open one of our branches, and like discussed, we could add more activities inside these branches. However, we cannot add another if activity inside our current if activity. So nested if activities are not supported. There are some workarounds that you could do, like use the switch activity instead of if activity, to which you can specify multiple branches if that is the case you need. If you would really need to have another if activity inside your if activity, then you would need to add invoke pipeline activity inside this if activity and have another if inside that pipeline which is being executed by that activity. However, this can get very complex very fast, and for those cases I would start looking at some other tools in Fabric, like notebooks that can handle way more complex logic than pipelines. But now let's talk about the for each activity. That is one of the most powerful activities to learn in Microsoft Fabric data pipelines, since it will allow you to add some iterative logic to your pipelines. That will make your pipelines way more efficient and faster to develop. In this video I first cover how the for each activity works on conceptual level, and then we will have a demo/tutorial where I show how it works in action. But now let's get started. First, let's imagine a situation that we have a CSV file in our lakehouse, and we would like to copy this file to a lakehouse table. In Fabric, we have multiple ways of achieving this goal, but using data pipelines is one of the easiest way of achieving this goal, and building this kind of pipeline is a really simple task, and one copy activity in a pipeline should be enough to handle this case. But what if instead of one file, we would have 20 files that we would like to copy to 20 different tables? This would mean that we would need to add 20 copy activities and configure them separately. That is already a quite time consuming and makes our pipeline a lot more complex. This is the stage when for each activity steps into picture, since we can just wrap the copy data activity to a for each activity and then iterate over it 20 times, thus reducing the number of activities from 20 to just 2. Now let's take a closer look at how for each activity works, and here we can see how does the for each activity look in the data pipeline UI. For each activity is an activity that takes in an array of items. For example, simple array of string items could just contain 2 strings. These arrays can be also way more complex, like arrays of objects with multiple layers that will allow you to build very powerful configuration-based logic to your pipelines. For each activity is an activity that wraps other activities, meaning that activities can be added inside the for each activity with some limitations. In this sense, for each resembles quite a lot of the if condition activity that we covered in the previous video. When the for each activity executes, it will run all the activities for every item in the list. Now let's go through how this iterative logic works. Here we have our for each activity. Inside that activity, we have another activity that we would like to execute as part of our for each logic. Then we have our array of items. In this case, we have 3 items that we are going to pass down to our for each activity. The values in this array could be any data type that are supported in data pipelines. So basically we could have an array of strings or maybe an array of integers, or in some cases we could even have an array of objects that we could pass down to the for each activity. In this case, I'm just representing the items as item 1, item 2, and item 3 to simplify this example. Inside these activities in the for each activity, we are going to reference these items with the reference @item. This will fetch the current item in the loop from the list of items that we are running in the for each activity. So during the first execution of the for each activity, this item reference will fetch item 1 from our array and use the value in our activities. After we have executed all the activities in the for each activity, we start over. Now we have again the item reference, but since this is an iteration number 2, we are now going to fetch the item 2 from our list using the @item reference. After our second iteration is done, we have the third iteration, and then we are going to again use the @item reference and fetch the item 3 from our list. This is the last iteration, so after we are done executing all the activities for this iteration, we are ready to continue forward from the for each activity. Next, let's digest this for each notation a bit more and use a bit more complex array that has 2 objects inside it as an example. In those objects, we have 2 properties, src file and dst table. Then we can imagine that we are passing this array to our for each loop, in which we would then refer those objects in the dynamic content of our activities. If we would like to refer those 2 objects, we would use the @item reference. In the first iteration of our for each, that item would be replaced with our first object, and then in our second iteration it would be replaced with our second object, and so on if we would have more objects in our array. Then what if we would like to refer these properties inside of our objects? For referencing src file property, we would use .src file after our @item, which would then get the value stored in our src file. That would be file 1 for the first iteration and file 2 in the second iteration. Same logic applies to our second property, dst table, and it would be referred by using .dst table after our @item. Now let's hop into Fabric and let's do a quick demo/tutorial together so we can see how the for each works in action. Also, all the files that I will be using in the tutorial can be found by clicking the link in the description. First, we can go and take a look at my lakehouse, where I have created a new folder called Fabric DE Series 9 Source. In this folder, I have 2 CSV files, animalsfile.csv and moviesfiles.csv. In both of these files, I have a header and few rows of data. Our goal in this tutorial would be to copy these files from our file section into tables in our lakehouse, so that the data in animals files would go to animals tables and the data in movies files would go to movies table. Also, since this is a for each tutorial, we don't want to use 2 individual copy activities to achieve this task. Instead, we are going to use the for each activity and 1 copy activity to achieve this goal. Let's navigate to Create and let's select Data Pipeline and name our pipeline according to our naming conventions. Then we would like to start by adding just 1 activity to our blank canvas, and this time this activity is going to be for each activity. Before we start the actual configuration, let me quickly explain the different settings in the Settings tab of our for each activity. The first setting here is the sequential setting, and by clicking this active, our for each would execute iterations in sequential manner, meaning one by one. You can also see that our second setting disappears if we click the sequential setting as active, since our second setting controls how many parallel executions our for each could be doing at the same time if we are not running it in the sequential mode. To our last setting, we would configure the array we would like to loop through in our for each activity. Now let's start the actual pipeline development work. First, let's click somewhere to the blank canvas so that we can see the parameters tab. And let's create a new parameter called file array to our pipeline, and let's change the type of this parameter to array, since this is the data type that our for each activity is expecting. To the value field as a default value, I'm going to add an array of objects. In this array of objects, we have two objects, so one object for each file. Both of these objects have the same properties, source file and destination table. The value for those properties in each object differ, and the first object has the values for our animals file and the second for our movies file. Next, let's configure our for each by first naming it to for each file in file array so that it describes what our for each does. Then we want to go to Settings tab and add dynamic content to our item settings. Here we want to use our file array parameter, so we can select it. Next, we can add one copy activity to inside our for each loop. Let's name our copy activity to copy data from files to tables. Then we can proceed to our source configuration and select our lakehouse and use the files as our root folder. Then to the directory we can type our lakehouse folder name. That in my case was Fabric DE Series 9 source. To the file name we want to add some dynamic content, since the file name is coming from our array that we are iterating in this loop. We can see that now we have this for each iterator tab here, that we have this current item available. We can click it, which will then just add this @item reference to our expression. However, if you remember from our previous section, this will now refer to the object in our array, and now we would like to use the source file property here. So we need to add that .source file reference here using that object notation. Now this expression would point to that source file property in our object. Then we can click OK. Then we want to change the file format from binary to delimited text and click preview data to see that we have configured everything correctly for our source. When clicking this preview data, we have to provide the value for our expression so that Fabric will know which file we are trying to preview. We can write here movies_file.csv, which will then start to load up a preview that would take a little while to load up. Now our preview is done and we can see that the data looks good, so we can move into configuring our destination. Here we want to select our lakehouse again as our destination. This time root folder is going to be tables, and now we want to add some dynamic content to our table name. This will happen in very similar manner that it happened for our source, but now instead of source file, we are going to refer to destination table property of our object. Also, we can go to the advanced settings and change our table action from append to overwrite, so that we will always overwrite the table with new data when we run this pipeline. And now we have configured everything and we can run our pipeline, which will then prompt us to give a value for our parameter. But since our default value is fine, we can just click OK and go with that. Now our pipeline starts to run, which will take a little moment. As we can see from the execution, we have two copy activities executing at the same time, since we are running our for each in parallel and not sequential mode. We can also check from our inputs of our copy activities that what kind of values went to those dynamic fields. But now our pipeline has executed and we can check out our lakehouse. In our lakehouse we can see those two tables and we can preview the data in those tables, and it looks good. So it seems that everything went as we wanted. Now let's go back to our pipeline, since I want to tell you about one key limitation with for each activity. And this limitation is that we cannot add another for each activity inside another for each activity. The workaround for this case would be to add invoke pipeline activity inside this for each activity, and then invoke a pipeline that would have a for each activity inside it. But this would get pretty complex pretty fast, and I would really start to look at other tools in Fabric to achieve this complex logic, like for instance notebooks. But now let's talk about the lookup activity. That is one of the most essential activities to learn in Microsoft Fabric data pipelines, since it will allow you to fetch some data from a data store and use that data as part of your data pipeline processing logic. In this video, I will first cover how the lookup activity works on conceptual level. Then we will have a demo/tutorial where we use this lookup activity on a data pipeline in Microsoft Fabric. Let's get started. Let's imagine a situation where we have a Fabric data pipeline. In that pipeline, we have a copy activity. We also have a lakehouse, and in that lakehouse, we have a configuration table. We would like to use the contents of this configuration table to instruct our copy activity to copy some data. How we would do this? Of course, we can use the lookup activity in the data pipeline and fetch the contents of the configuration table and have them available in our pipeline for our copy activity to use. Now let's take a closer look at how lookup activity works in data pipelines. The lookup activity can retrieve contents from a dataset that is sitting in some data store. It has two options: to retrieve the first row from the dataset or retrieve all the rows from the dataset. However, there are some limitations on how much data the lookup activity can return. A maximum of 5,000 rows and a maximum of 4 megabytes. After the lookup activity runs, the contents of its output can be used in the following activities as dynamic content. Let's take a look at how the inputs and outputs work with the lookup activity. For example, let's have a lakehouse with a configuration table that has two columns, source file and destination table. On the first row, the source file is currency.csv and the destination table is currency. On the second row, the source file is money.csv and the destination table is money. We would like to use these values in our pipeline to copy the contents of the currency.csv to currency table in the lakehouse and money.csv to the money table in the lakehouse. This table will be the input for our lookup activity. Let's configure our lookup activity to only retrieve the first row. When our lookup activity runs, our output will be the first row of this table, meaning we only get the source file and destination table of the first row, currency.csv and currency. These two values are wrapped in an object called first row. Next, let's run our lookup activity again, but this time we will uncheck the first row only setting. Our lookup activity runs, and we see a different output. We get the count of how many rows were retrieved and the value array containing all the rows that were retrieved. In this case, we have two rows, so we get both the currency and money configuration from the configuration table. Now this output of the lookup activity would be then available to use in the following activities in our pipeline. For example, we could pass this value array for a for each loop and start to iterate it and do actions based on the configuration data. Now let's hop into Fabric and let's do a demo/tutorial together so you can see how the lookup activity works in action. Also, all the files that I will be using in the tutorial can be found by clicking the link in the description. Let's first open up my lakehouse where I have created a new folder, Fabric DE Series 10, and in that folder I have two files, one CSV and one JSON file. In the CSV file, I have a header and two rows of data, and in the JSON file, I have an array and two objects with two properties in each object. Some of you might recognize this content from the previous video on this series where we covered the for each activity and used this same data as our input for our for each loop. Now we would like to use the lookup activity to retrieve the content from these files so that we can use that content in our data pipeline for processing logic. So let's click Create and select a new data pipeline and name that pipeline according to our naming conventions. Then we want to start with a blank canvas and just to add lookup activity to that canvas. So let's select it from the list of available activities. Then we want to open up the settings tab of our lookup activity, and as a connection we want to use our lakehouse and change the root folder to files. First we can try to look up the contents of our CSV file. So let's point our lookup activity to that file by writing the folder first to our directory in our file path, and after that we want to input the name of our CSV file to the file name field. Of course, you could do the same thing by using the browse feature and find the file in our lakehouse, but it is a slower way of doing things. Everything else should be correct, since file format is already delimited text and our file should follow the standard delimited text configuration. We can then click preview to confirm that we have configured everything correctly. After our preview is done loading, we can see that in our preview we only have a one row of data. If you remember, our CSV had 2 rows of data, and the reason why we are seeing only one row here is in our lookup activity settings, since we have configured it to only fetch the first row only, since that is the default setting. Now let's deselect that setting and preview our data again, and let's wait for our preview to load up, and now we can see both of those rows in our preview. Let's turn the first row only setting back on, and then let's run our pipeline to see how does the output of our lookup look like. Now our pipeline is running and should be done quite shortly, since lookup activity should be very fast activity to execute if files or tables are small. Now our pipeline is done and we can check the output. We can see that our output is a JSON object with a property called first row, and in that property we have another object with true properties that match with the columns in our file. Next, let's go back to our lookup settings and deselect that first row only option and run our pipeline again. And this time also our pipeline should succeed quite fast, and now it is done and we can check the output. We can see that again our output is an object, and now in that object we have 2 properties, count and value. Count indicates how many rows were retrieved, and in the value we have an array that contains those rows wrapped to objects. Next, let's try to look up our JSON file. So let's go back to our lookup and change the file name of our file to point to that JSON file, and then also we have to change the file format to JSON and leave the first row option off this time. Again, let's run our pipeline to see how the lookup activity behaves with the JSON file. Then we wait for our pipeline to succeed, and now it is done and we can check the output of our lookup activity that looks pretty much the same as with our CSV file. Next, let's modify our pipeline a bit and add for each activity after our lookup activity, since I want to show you how you can refer to that lookup activity output in the following activities. I already covered the for each activity in great detail in the previous video in this series, so go check that out if you are not familiar with this activity yet. But now let's open the settings tab of our for each activity and use dynamic content for our items section. In our pipeline expression builder, we can see this tab called Activity Outputs, and here we can see some outputs from our lookup activity. If you remember, our for each is expecting to have an array as input, and when we don't have that first row only option selected in our lookup, we will get that value array that we can then pass to our for each activity as input. That value array can be found from this activity output list, and we can select that and click OK. Then we can add a wait activity to inside our for each just to see how many times our for each will iterate. Then let's click run and see what happens. Now our pipeline is running and should finish in just a moment, since we are not running anything particularly heavy or time consuming here. Now our pipeline is done and we can see that our for each iterated 2 times, since our wait activity was executed twice. Now let's break down a bit what happened here. First, our lookup activity executed and fetched the contents from our configuration file. Then we passed the value array from our lookup activity to our for each loop, that is the activity that will iterate over arrays. Even though we didn't actually do anything with our configuration data inside our for each loop, you most likely get the point that now we could have had there, for example, a copy data activity that we could have used dynamically to copy files based on our pipeline configuration. We're going to come back to this concept of using lookup activity and for each activity to build these configuration-based or metadata-driven pipelines. So don't worry if you didn't manage to understand that well what was happening here. We will come back to this. Also, I want to note that even though we used files in this example, the process is pretty much the same to every other data store. So it doesn't really matter if we are using files or tables as a source for our lookup activity. The outputs from the lookup activity will be the same. But now let's talk about the get metadata activity. That is one of the most essential activities to learn, since it will allow you to fetch metadata about datasets and folders in data stores and use that metadata as part of your data pipeline processing logic. In this video, I will first cover how the get metadata activity works on conceptual level, and then we will have a demo/tutorial and use the get metadata activity in data pipeline in Microsoft Fabric. Let's get started. Let's imagine a situation where we have a lakehouse. In that lakehouse, we have a CSV file. Then we have a Fabric data pipeline. In that pipeline, we have a copy data activity that would copy the contents of this CSV file. However, we have wrapped this copy data activity in an if condition, and we would only like to run this copy activity if the CSV file has been modified during the past 24 hours. How we would do this? Of course, we can use the get metadata activity in the data pipeline and fetch the last modified timestamp of the CSV file, and then we have the logic in our if condition to only run the copy activity if the CSV file has been modified in the last 24 hours. Now let's digest this get metadata activity in a bit more detail. Here we can see how the get metadata activity looks in the UI. This is an activity that retrieves some metadata information about the data set. There are several different types of metadata that are currently supported depending on the source of the data set. The maximum size of output for this activity is 4 megabytes. The output of this activity can be used in the following activities as dynamic content. This activity is somewhat similar to the lookup activity that we covered in the previous video in this series. Now let's take a look at a couple of these options and the kinds of outputs they would yield in data pipelines. Let's have a lakehouse. In that lakehouse, let's have a CSV file and call that file1.csv. Then we're going to have a get metadata activity in our data pipeline. First, let's set the option of the get metadata activity to last modified. Now when our get metadata activity runs, we can see that it will output the last modified timestamp of that file. Next, let's change our get metadata activities option to exists and run our get metadata activity again. Now we can see that our return value is a Boolean value. And it is now true since our file is there and exists. If our file didn't exist, the get metadata activity wouldn't throw an error but would return false. Lastly, let's set our option to structure and see what kind of output our get metadata activity would now yield when it runs. We can see that after it runs, we get the structure array in the output, and it has all the columns and their data types that we would have in the CSV file. Like the lookup activity, the outputs of the get metadata activity would be now available to be used in the following activities as input and dynamic content. This would allow us to build some extra logic into our pipelines based on the get metadata activity's outputs. Now let's hop into Fabric and let's do a demo/tutorial that will help you to see and learn how the get metadata activity works in action. Also, all the files used in the tutorial can be found by clicking the link in the description. Let's first open my lakehouse, where I have created a new folder called Fabric DE Series 11 and added one file to that folder called movilsfile.csv. In that file I have a header and few rows of data. Next, I would like to use this file as an example to demonstrate how the get metadata activity works in data pipelines. Let's hit create and find data pipeline and create a new data pipeline and name it according to our naming conventions. Then we want to start with a blank canvas and just to add one activity to that pipeline, that is going to be of course the get metadata activity. Next, let's open up the Settings tab of our Get Metadata activity and choose our lakehouse as the connection for it. Then we want to use files as our root folder and make sure that our directory and file are pointing to that file that we want to use in this demo. And since we're going to have a CSV file, we can change our file type to delimited text. That will give us possibilities to fetch more metadata out from the file compared to a situation where this was just a binary file. Next, we can configure our field list that determines which metadata is fetched from the file. As we can see from the available list, we have plenty of different options available here. We can, for example, fetch the column count from the file, check if the file exists, get the last modified timestamp, or to check the size of the file. From this argument list, let's pick the exist metadata and then last modified, and lastly, let's get the structure of the file. Now we have configured our Get Metadata activity and are ready to run our pipeline. Let's click Run, which will then start a pipeline run that will execute our Get Metadata activity. Now our pipeline run has completed and we can check what kind of outputs the Get Metadata had. We can see that we have their execution duration, and then we have those three metadata properties that we configured our activity to fetch from our file. First, we have a property called exists that has a boolean true as its value. The property tells that whether or not the file exists, and since our file is in our lakehouse folder, it returns true. Then we have the last modified timestamp of our file. This is now basically the timestamp when I uploaded that file to that folder. Then lastly, we have the structure information of our file that tells which columns can be found in that file. Next, let's modify our pipeline a bit and add if condition after our Get Metadata activity. To this if conditions expression, we want to use the output of our Get Metadata activity. When we open up the expression builder, we can see those Get Metadata outputs there. One of the easiest outputs to use here is the exist information, since our if condition is expecting to have a boolean value as a result of our expression. So we can select that exists information from our output list, which will then create the required expression. By using this expression, we would go to the true branch of our if condition if the file exists, and to the false branch if the file does not exist. For demo purposes, we can add wait activities inside our branches and name them according to the branch, so we can see in the pipeline output to which branch the execution went. Then we can run our pipeline and wait it to finish the execution. Now our pipeline is done and we can see that our if condition went to the true branch since our file can be found in our lakehouse. For example, now we could have a copy data activity in our true branch and copy the file to our lakehouse table. And in this video, we are going to cover how to schedule and monitor data pipelines. But now, without further ado, let's fire up Fabric and check out how scheduling and monitoring works there. Now we have the Microsoft Fabric open here. Let's open up the Data Factory experience and create a new data pipeline. And we will have to name that pipeline according to our naming conventions. Then we want to start with the blank canvas after this loads up. And to this pipeline, we can just add one wait activity, since the purpose of this video is to demonstrate how the scheduling works and not to build actual pipeline here. In the previous videos, we have ran our pipelines by just clicking this Run button here. That would trigger a manual pipeline run for this pipeline here. But today we're going to cover the schedule feature here in pipelines. And next to that Run button, we have this Schedule button here. And by clicking this, it will open up this configuration for our pipeline schedule. Currently, we haven't defined any schedules for this pipeline since we just created this one. But here we could turn this schedule run on. And by clicking that on, this will open up these other settings here that we have. First, we could select when we want to repeat our schedule. By default, this is by the minute. And here we would configure every minute we would want this pipeline to run. For example, every 15 minutes or every 1 minute. And then we would have to configure the start date and time for this pipeline. Usually you want to have this in the past. It's pretty safe to input there the current timestamp that you have currently. and I will do that. Then we would have to configure the end date and time for this pipeline. This is actually a mandatory setting that is a bit strange in my opinion, since in some cases you want your pipeline to run basically forever or until you manually turn that off. But here I would recommend just setting some time that is very far in the future if you don't have any cases that you would need your pipeline to stop running at a certain date. Now let's configure tomorrow there just for demo purposes. Okay, then you could pick a time zone when you want your pipeline to run. I'm in Helsinki, so I pick the Helsinki time here. Now basically we would be able to apply this schedule, but let's not do that just yet. We could check these other features that we have under this repeat here. We could, for example, repeat this hourly. Then we would select every hour we want this to run, maybe every 1 hour. Then we have the daily schedule. Here we would schedule the time we want this pipeline to run daily. For example, maybe we want this to run 8 a.m. each morning. And the cool thing here is that we can specify multiple times that we want this pipeline to run each day. So it's not limited just to one time. Then lastly, we have this weekly scheduling here that we can select the weekdays we want this pipeline to run and then the times we want it to run. Basically, this extends the daily scheduling a bit, so we could, for example, skip the pipeline run during the weekends if it's not necessary or so. But for now, let's go back and change this to by the minute and select every 1 minute, and let's click apply so we can see how our pipeline will run. And now we have applied this schedule to our pipeline. And good thing to note here that we can only have one schedule defined to one pipeline. So basically, if you're coming from Azure Data Factory world, there you could have multiple triggers tied to one pipeline, but here is just one schedule per pipeline. Now let's allow this pipeline to run for a moment and let's close this schedule window here. And let's create another data pipeline here, because I want to demonstrate to you one other point about this scheduling. To this pipeline also let's add wait activity and let's add a few parameters here. Let's add, for example, param1 and param2. And let's have them as string values. Now I want to talk about one key issue with these parameters. If you're coming from Azure Data Factory or Synapse Analytics world, you know that if you tie a trigger to a pipeline, you are able to define the parameter values for that trigger. But with scheduling, you don't have that option here in Microsoft Fabric. And basically only the default values for these parameters would be used when scheduling the pipeline. Now you could be wondering how you can get the trigger time of the pipeline, for example, and use that as part of your pipeline logic. In the Data Factory and Synapse Analytics, you would usually use trigger properties to derive those values and pass them as parameters to the pipeline. But here things work a bit differently. This is also doable here, but you have to use a workaround. For example, to get that trigger timestamp, we can actually use some predefined system variables. Let's add set variable activity here and let's go and define a new variable to this pipeline and call that var1. And then we can set value for this var1 and open the dynamic content. And here we have some system variables here, and one of these is the pipeline trigger time. And by using this system variable, you would be able to get the time when the pipeline was triggered in UTC format. And then you would be able to use that value as part of your pipeline logic. So things work a bit differently here compared to Azure Data Factory and Synapse Analytics. But this similar information is available here as well. Next, let's go to the Monitor Hub and check out how our pipeline has been running that we just scheduled. Monitoring Hub can be found here in the left bar. And here we can see the pipeline runs that have been running here. And we can see that our pipeline has been already running quite many times since I scheduled it to run every 1 minute. And here we can check out what is happening in this pipeline or what happened during the run. Here we have this view where we can see how did the activities execute, and here we would see all the activities and what were their statuses and did they have any errors if we would have more activities here. But since we only have the wait activity here, we cannot see that much here this time. We also have this Gantt view here that is not very well demonstrated here since we only have one activity, but basically this would show this kind of a visual illustration when did those activities run compared to each other. If you have a pipeline with multiple branches and multiple activities executing in those branches. But now let's go back to the monitor hub. Here we could monitor our pipeline runs, and we have some filters to filter out, for example, if we want to only see the succeed pipeline runs or maybe the failed pipeline runs if we're investigating failures here. Also, we are able to modify these columns that we have here and add some more columns to this so that we can get more information to this view, what has been happening with our pipelines. Also, one cool thing to note about this monitoring hub that in the Azure Data Factory, for example, you can only see the pipeline runs that are happening in the data factory that you are looking at. But in this Fabric Data Factory and this monitoring, you can see basically all the pipeline runs in every workspace that you have access to with your account that you have logged in. So basically we would able to see all the pipeline runs in different environments if we think about it that way. In this video, I want to talk about data pipeline return values. In many cases, when building more complex data pipelines, you could have many layers of pipelines, meaning that you have a top-level pipeline that will then invoke some lower-level pipelines. In some cases, you might have a need to pass information from a lower-level pipeline to that top-level pipeline, and possibly do some following things in that top-level pipeline based on that information. One example of this could be that you have a pipeline that will copy something using a wildcard, and if there are no files copied, you don't want to run following pipelines. With return values, you can achieve this. For people more familiar with programming and functions, these return values should make quite a lot of sense, since you can think about one pipeline as one function that has a return value. But enough talking, and let's open up Fabric and check out how these return values work in action. Now I have the Fabric Data Factory experience open here. Let's start by creating our lower level pipeline, and let's name this pipeline according to our naming conventions. So this is going to be the pipeline that we are going to invoke in the upper level pipeline that we are going to create shortly. But now let's add just set variable activity to this lower level pipeline. We have covered already in the previous videos how we can use the set variable activity to set pipeline variables. But there is another functionality to the set variable activity as well. And we can see that by opening up the settings tab. And here we can see that we can select the variable type. In this case, we want to select the pipeline return value, and we can see what happens then. We can click that, and then we can start to define pipeline return values here. This means that these values would be returned from the pipeline when the pipeline executes. Now let's define a few return values here. Let's name them RV1, RV2, and RV3. And here we can see that we have plenty of different data types supported here that we can use for these return values. For example, we have string, then we have expression, then we have object, array, integer, float, boolean, and null. We can, for example, use string value for this RV1, and right here this is a return value. And then for the RV2, we can add, for example, let's try the array return value. And here we can define the data that we want to be in our array. Let's put A to our first index, then B as our second index, and then C as our third index. And then for the RV3, I can think we can take, for example, the expression. As you can see, we cannot use the dynamic content for this string return value here, but with this expression type, we have this dynamic content available here. And we can just add a simple function here, for example, UTC now function, and return the value of that in our return value. Then we can click OK. Now we have set up 3 return values here, and then we can run our pipeline by clicking Run button. This will save and run our pipeline, and now our pipeline is running and should finish very quickly since we are not really doing anything special here and it's already done. And then we can check the outputs of this set variable activity. We can see that we have here this value object, and inside that we have all of those 3 return values available. At this point, this reminds quite a lot of using just regular variables in the pipeline. But these values are a bit different since these are available as return values from the pipeline itself if we would execute this pipeline as part of another pipeline. And now let's create another pipeline. And let's find the data pipeline here. And then we can name this pipeline according to our naming conventions. And to this pipeline, we want to add the invoke pipeline activity. And with this activity, we can invoke another pipeline within this pipeline. And this time we want to invoke the pipeline that we just created. And now we have set it up. So we have selected the invoked pipeline to be this pipeline that we just created. And now we can click Run and let's see what happens when we do that. This should also finish very fast since we are not doing anything special here. Let's see, it should be done fairly quickly, and it's already done. And now we can check the outputs of this pipeline. As we can see, we cannot see the return values here. That is, in my opinion, a bit bad. And I would like to see the return values here in the pipeline output. Instead, what we have to do, we have to click this link here that points to the pipeline run ID and go there and check out the outputs here, what happened. This is a little bit inconvenient, and I hope Microsoft would do this in a bit easier fashion than this. But basically, now we have invoked that pipeline, and even though we cannot see here that we have those return values coming from that lower level pipeline, trust me, they are there. And now we can add a bunch of set variable activities to this upper level pipeline and then use these to reference the return values that are coming from this invoked pipeline. Let's create those variables here, var1, that has to be string, and then var2, that was an array, and then var3, that is also a string because our UTC now function that is coming here will give us a string value when it evaluates. But yeah, now we can assign those variables here in the set variables activities to see how you can reference those return values. Let's assign the value var1 and let's assign it the value of rv1 here. And then to the var2, rv2 and the var3, we are going to assign the rv3 value. But yeah, let's assign their value, and when we open this dynamic content here, we can see this invoke pipeline 1 activity output. And here we have this return value available. We can click this, but this would give us the entire return value that's coming in. We can just pick one out of those return values by typing a .rv1 here. That would basically take the rv1 out of this entire return value here. Then we can click OK. To the second variable, we want to assign the array that is coming from our return value that is from in rv2. And then to the third, of course, we want to assign the rv3. There we go. And now everything should be set up correctly here. So basically what's happening here, we are invoking that lower level pipeline that has some return values, and then we are assigning those return values to variables here in the top level pipeline. And I'm just using these variables as an example here to show you how you can reference those activity or those pipeline return value outputs here. Basically, you could just have a bunch of different logic based on those values that are coming from the lower level pipeline, but this is just a simple illustration. Now let's click Run and let's see what happens. And now our pipeline is running and should finish very quickly since we are again not doing anything very special here, just assigning some values. And now it is already done. So we invoked first the pipeline, and then we had some return values coming from there that we can see by going to this lower level pipeline and checking this set variable activity. Here we have all those values, so RV1, RV2, and RV3. And then in the top level pipeline, we're assigning them to variable 1, and we can see what is the variable 1 output. Here this is a return value. That's correct. And then in the second variable, we should have that array. And yes, we do. And then in the third, we should have a timestamp in UTC format. And there we have it. But yeah, this is how you would use return values in the pipelines to pass information from a lower level pipeline to a top level pipeline. But now let's talk about activity inputs and outputs. That is a topic that we have used already in the previous videos. But today we are going to dive a bit deeper into it and clarify a few things about it. This is a topic that is better explained using examples, so without further ado, let's fire up Fabric. Now I have the Fabric open here. Let's first open up my Lakehouse, where I have created this new folder with two subfolders, source and destination. In our source folder, we have this one file called file1.txt, and in this file I just have random content here. I'm just going to use this file to explain few topics about activity inputs and outputs. But for us to demonstrate those, we have to create a new data pipeline. So let's hit create and let's find data pipeline here. And then we're going to name that data pipeline according to our naming conventions. And after that, we are going to start with a blank canvas, and we want to add just a copy activity to this canvas. And we can just name this copy data file1. And now let's configure this copy data activity to copy that one file from that source folder to that destination folder using binary copy. We have done this thing in the previous videos multiple times before, so I'm not going to explain each step in that detail this time. So let's configure our source. Let's find our Lakehouse. It is there. And then we are going to use the file section. And then we have to input our file path, where our file is, and then we want to input our file name there, and we're going to use binary copy, so everything should be configured correctly to the source side now. Then let's configure the destination. We're going to use the same Lakehouse this time and change the section to files, and then the destination path, we're going to input that and add the file name there. So basically now we have configured our copy data correctly, and we can click run and see what happens. And now our copy data is running. Should take a little moment it to run. And now we can already start to talk about activity inputs and outputs while this is running. Basically, when we configure this copy data, we are configuring some things to the source and to the destination. Basically, these things that we're configuring here are the inputs for this activity. And now our copy data has finished, and here we can actually find the inputs that went to this activity in JSON format. We can check this out. So basically here is the activity input that went to that activity. That is basically the configuration for that activity that tells what needs to be done in that execution. So here we can see some familiar things that we configured there, like that the source type is binary, and we are using Lakehouse and our Lakehouse name and some workspace IDs, etc. here that are hidden in that view. But yeah, here are the inputs that went into that copy data activity. But the more important topic today is going to be the activity outputs. So almost every activity in the data factory or in these pipelines that does something has these outputs. And here in the output tab, we can see the outputs that came out from that copy data activity. Basically, these tell what happened during that execution. Here we have information, for example, about how much data was read and how much data was written, and how many files were read and how many files were written, and some other information about that copy data activity. And now you could be wondering, what is the point of this video today? The point today is that we can actually use this information in the following activities to build some logic. For example, very useful information here could be that how many files were written to the destination. In some cases, for example, if you are reading files using a wildcard, it could be that there is 0 or more files coming in. And then you might want to have some logic based on that how many files were copied forward. Basically, if you have 0 files coming in, then maybe you don't want to do anything in the following step. So you could have an if activity that would say that no things need to be done if the file amount is 0. And now we can try to illustrate that situation here in the pipeline. So let's add if activity to this pipeline, and then let's add just wait activities to those branches so we can see to which branch the execution went, and let's name those wait activities according to branch they are in. So let's have their false. And then we want to configure an expression for this if activity. And we can use dynamic content to do that. And here we can see that we have these activity outputs here. And this time we're interested in this copy data file 1 activity output. And what this would do, this would reference that object that we saw there. So basically this would reference this object that we have here. So if we would, for example, like to get the files written here, we would have to say dot files written after that activity output, so it would get that property there. So we can do that. So if we want to use that there, we would say this, and then we would say files written, and this would then get that amount of files written here. But if you remember, if condition expects to have a Boolean value, and now we would just give it an integer value here. So we can do a logic check to check here whether or not the amount of files written was 0 or not. So basically we can use a greater function there to check is the amount of files written greater than 0. And now this logic will return true if the files written is greater than 0, and if it's 0, it will return false. And now we can just save this and then run our pipeline again. And now our pipeline has succeeded, and we can see that our pipeline went to that true branch, meaning that this condition here evaluated to true. And now I will clarify a bit what happened here a bit more. So we had that copy data activity here first, and this activity has some inputs and it has some outputs. And when this activity runs, it provides us that output that tells what happened during the execution. And we get this long list of data out from that activity. And then it is possible to reference that data using this syntax that I showed to you. So basically activity and then the activity name dot output and then the dot information that we want to take from that output. In this case, we want to have that files written. And then we had some logic based on that files written, whether it's 0 or not. Okay, but yeah. And also keep in mind that these activities have to be in a logical order in order this to work. So if we would have this copy data activity after this if condition, of course this logic doesn't work, because when the pipeline executes, the logical flow would execute the if condition first, and then we don't have that activity outputs available from that copy data yet. So we can see the error here that it doesn't work this way, because it cannot be referenced. But yeah, using these activity outputs is a very convenient way to build some logic to your pipelines without using additional activities. For example, other way to check if the file exists in the destination folder would be using get metadata activity, but in this case it would be pointless, because we can get that information from the copy data activity itself and its output, that how many files were written. So there is no need to do an additional check using get metadata. So we can reduce the amount of activities by utilizing these activity outputs in our pipeline. But now let's talk about the switch activity that provides the same functionality that a switch statement provides in programming languages. For people not so familiar with programming, I would say that this is kind of the big brother of the if condition activity that we have already covered in the previous episode in this series. Since the switch activity allows you to add multiple branches compared to just 2 branches that were available in the if condition. But enough talking, and let's fire up Fabric and do a quick demo/tutorial together to see how this activity works in action. Now I have the Fabric open here. Let's start by creating a new data pipeline, and let's name that pipeline according to our naming conventions. And then we want to start with a blank canvas. And this time we want to add the switch activity to that canvas. And here we can see how does the switch activity look in the pipeline UI. In here we can see that this is an activity that encapsulates other activities, and we can add other activities inside these branches that we have here. Currently we only have this default branch here, and let's just add wait activity here and name that default, so we can see when the default branch is used. But the point of this activity is not just to use this default branch and add there a bunch of activities. The point here is to add some other cases or branches here where we can have different activities. So let's open up this activities tab of our switch activity. And here we have this button add case, and let's add a couple of more cases here. Now we have cases 1 and 2 here. Let's name those cases a bit differently. Let's name the case 1 as file 1 and case 2 as file 2. And here we can see that we could add now some activities inside these branches as well. Let's add wait activities to both branches, and let's name those activities based on the branch they are in. And here we add file 2. And now we have 3 wait activities inside our switch activity, but all of those activities are inside different branches. So we are not going to run these during the same execution. And now we can talk about how we decide which branch we are going to use when the pipeline executes. The way how we decide which branch will be used is defined by this expression here. And if you remember, when using if condition, we have these 2 branches, and our if condition is actually expecting to have a Boolean expression. So we decide, do we go to the true branch or the false branch? The switch activity is a bit different, since this expression have to evaluate the string value, and then that string value has to match with one of these cases here. So basically the string value coming out of this expression would have to evaluate either to file 1 or file 2. And if it doesn't evaluate either of those, then this switch activity would go to this default branch that is always present here and always mandatory to have. In many cases, you most likely want to use the switch activity after you have run some other activities and used their output and use that as part of the expression here. For example, you could have a get metadata activity that would check what is the file name that you have in your storage and then do things based on that. But now let's keep things simple and let's just add parameter to this pipeline, and let's call that file name, and let's add default value file 1 here, and then we would have to use this parameter value here in the expression, so we would be able to pass it down to this switch activity. So basically now we have that parameter here, and based on that parameter value we are going to decide which branch we are going to go, since we are just using that raw parameter value here in the expression and we're not doing anything too fancy here. Let's now run this pipeline and let's see what happens. And for the parameter value we can use the default value of file 1 this time. And now our pipeline is running, and I think it should finish really quickly since we are not doing anything special here. And we can see that our switch activity went to that file 1 branch since we ran that file 1 wait activity there. And you can see that we didn't run the default wait activity or file 2 wait activity. And now let's run this pipeline again, and let's type here file 3. And as you can see, we don't have file 3 branch available here. This would mean that now we go to the default branch, and like we did. But now let's open up Fabric and cover some pipeline best practices. Now I have the Fabric open and blank pipeline canvas here. We can add just copy activity to this canvas to demonstrate our first best practice. And our first best practice is going to be this retry functionality in these activities. Many activities that do some external actions, meaning that they are not like pipeline logic things like wait activities or filters or add variable activities, have these retry functionalities built in. This means that the activity will try to rerun itself before throwing that end error status that it failed entirely. Also, one thing to note is this retry interval, where you can define the amount of seconds that you want to have there in between those retries. In my opinion, it is always a best practice to throw in at least a couple of retries per activity, since there could be, for example, some network-related issues going on that last only, for example, few seconds, but that few seconds is enough to fail that activity. So this means that your pipeline would become way more robust towards those tiny little network or some random errors that might occur, and then the pipeline would recover from those. The next best practice that I want to cover is this timeout setting in the activities. The default value for this timeout setting is 12 hours. At least with Azure Data Factory, I have ran into issues with these activities that they have gotten stuck, which means that they have run until they have reached their timeout limit. In many cases, you don't want this timeout to be 12 hours, since in most cases activities could only execute few seconds in most cases. So maybe you want to have their like 5-minute timeout or something like that. But yeah, this is something that you should also consider when building pipelines. But also there are situations where you might want to have more than 12 hours here. But this is a setting that you should pay attention to when building data pipelines. The third best practice that I want to cover is this pipeline level concurrency setting. And what this setting does, this defines the concurrency, how many times this given pipeline can be running at the same time. This is a very essential setting to consider, and in most cases you want this to be 1. Since probably you don't want to end up to a situation where your pipeline is running multiple times in parallel. For example, let's imagine a situation that you have a pipeline that is running every 10 minutes, and usually it takes like 2 minutes to complete. But for now, some reason it is taking over 10 minutes to complete. If you haven't defined this setting in that scenario, you will end up to a situation that you have 2 simultaneous pipeline runs for that same pipeline going on, and this could be hugely problematic in many cases. So always consider this concurrency setting, and in most cases you want this to be 1, so you don't end up to any messy situation. But there are also situations where you want this to be something else than 1. For example, when you have these like general pipelines or multi-purpose pipelines that can be used as sub-pipelines in some other pipelines, then you most likely want this to be something else than 1 or leave this completely empty. The fourth best practice that I want to cover is that you should utilize iterative logic in your pipelines. So this means that you don't want to have a bunch of copy activities in your pipelines that are basically doing pretty much the same operation and copying data, for example, from CSV files to some tables. Then it would be easier to just add 1 for each activity to your pipeline and then have that copy data activity inside that for each. I've already covered how to use for each activity in my Microsoft Fabric data engineering series, and you can check that video that can be found in the playlist. But using this iterative logic will save you a ton of development time when you have to configure only 1 copy data activity dynamically, rather than, for example, adding 100 copy data activities if you are copying 100 SQL tables to your lakehouse or something like that. Our fifth best practice is that keep it simple. You don't want to build very complex logic to your pipelines, and there are some other tools like notebooks, data flows, stored procedures, etc. in Fabric that you can use for more complex logic. So you want to keep your pipeline logic as minimal as possible, and then just add those more code and complex logical blocks to your pipeline to be run as part of your pipeline. But try to avoid building a lot of complex logic to the pipeline itself, because the pipeline is really not meant for that, and this kind of low code tools have their limitations when you try to build for example, multiple for each loops on top of each other. That's not what this pipeline is meant for. And that should be preferably done, for example, in a notebook. But now let's fire up Fabric and check out delete data activity in Microsoft Fabric data pipelines. Now I have the Fabric open and I have this pipeline here where I have added just this delete data activity. We can also check out our lakehouse, since I have added there a new folder, and in that folder I have this file1.txt that we're going to delete using the delete data activity. But let's go back to our pipeline. Let's first talk about a bit what delete data activity does. The activity's name pretty much explains what this activity does. This is an activity that is meant for deleting data, and especially files. This activity is particularly useful in situations where you want to delete the data after your pipeline has entirely run successfully. This means that you don't want to delete the files after you have copied them. That can be done in the copy data activity. Now let's go through some of the settings that we have in this delete data activity. First, we have to define the source. We can define the lakehouse that I just showed to you as the source, and then we have to define the file path where we can find our file. So I will write there the directory of our file and the file name. Now this delete data activity has been already configured to delete that file in that folder. And if we would run this, this file would now get deleted. But let's not do that just yet. Let's discuss a few more things about this delete data activity before running this pipeline. The setting that we have here under our path is the recursively setting, which means that if we would just specify folder here and not the file itself, the delete data activity would delete all the files in the folder and its subfolders. But since we have now defined the file here, this setting doesn't really do anything at this point. Then one important setting that we also have here is filter by last modified. Basically, we can filter files based on their start time or end time when they have been last modified. And this could be very important in your pipeline logic, because maybe you are running your pipeline and you are deleting the files after your pipeline has completed successfully. And this means that most likely you want to only delete the files that have appeared to that folder before your pipeline started running. So maybe you could use some dynamic content here and use some system variables like pipeline trigger time to only filter out those files that have been there before the pipeline started running. By using delete data activity using these filters, you would make sure that you don't delete any files that you haven't copied forward in your pipeline logic. But yeah, this is something that you should consider when using delete data activity. Also, we have this logging setting available here where we can log those files that have been deleted. Basically, those logs would tell which files were deleted. And now we have only options to define some Azure blob storages where we could input those logs. But since I don't want to log anything, I can just untap that setting. Next, we could try to run this pipeline and see what happens. And now let's run our pipeline and let's see what happens. Let's click save and run, and our pipeline should start running, and then we can see what happens. And now our pipeline has ran successfully, and we can go check out our lakehouse. Do we have that file anymore here? Let's refresh this folder, and that file is already gone. And we can check our output of our delete data activity to see what happens. This output gives us some information what happened during the execution. And like you know from the previous videos, we could use this output in the following activities to do some logic. But for example, here we can see that files deleted was 1. Which is correct since we only specified one file to be deleted. So everything went fine. But now let's open up Fabric and check out how to use the filter activity in data pipelines. Now I have the Microsoft Fabric open here and I have this blank pipeline canvas open. Now let's add filter activity to this canvas and let's talk about what this filter activity does. Basically, this is an activity that can be used to filter out arrays based on some condition. Basically, you can think about this filter activity as a loop that will iterate over an array and then select only those items from that array that meet the certain condition that has been specified. And now let's check out the settings tab of this filter activity. Here we have to define the list of items, basically an array that will be filtered by using this filter activity. And then we define a condition that filters out those items. Now let's demonstrate how this activity works by creating a parameter to this pipeline. Let's call that parameter as param1. And then we have to change the type to array and then just add a simple array to this parameter. In that array we have only 1, 2, and 3. So basically those numbers, and then we would like to filter out this. Now let's go to our filter activity and let's specify the items that we want to filter, and we are going to use that parameter that I just defined. So we can select that and then we can specify the condition that we want to use to filter out this. This filter activity works in very similar fashion as the for each activity, and basically we also have this @item reference that we can use to filter out items. And by using this @item reference we can refer to the current item in the loop. For example, if we have that array with 1, 2, and 3, then we would start to iterate over it and we would first check the condition for the number 1, and then we would check the condition for the number 2, and then we would check the condition for the number 3. And now we would like to build an expression that would filter out the number 2 out of that list. And that expression would go like this. First we have there the equals function that would check, is the item currently being iterated over number 2? And then we want to wrap this equals function to not function because we don't want to have that number 2. By combining these two functions we would create a logic that says not equals 2. Basically this means that if the items equal something else than 2, then it will be not filtered out. And good thing to note here that this logic in this expression with the filter activity has to resolve into a Boolean value, meaning true or false. And there are a bunch of different functions that will eventually resolve to a Boolean value, and these not and equals functions are just a few of those. But yeah, this expression is now ready and we can try to run this pipeline and see what happens. So then we have our parameter 1, 2, 3, and now we want to filter out that list. And now our pipeline has completed and we can check the output from our filter activity. We can see that we get this value out from our filter activity, and we can see that we have a list there or an array. And in that array we have only 1 and 3, which means that our filter activity dropped out that 2 from our list. Next, let's do a bit more complex example using this filter activity. Now I have another blank pipeline canvas open here, and this time I want to do a bit more realistic scenario using the filter activity. And we can check out my lakehouse where I have a folder, and in that folder I have 3 files, and we can see that we have 2 CSV files and 1 TXT file. In this scenario I want to first use the get metadata activity to read the child items of this folder and then filter out from that list only the files that have .csv ending. And we can go to our pipeline and do that. Let's first add the get metadata activity here. And we have already covered this get metadata activity in previous episode in this series, so I'm not going to spend that much time covering it this time. So let's select our lakehouse, and then we want the file section, and then we want to specify our directory. And from this directory we want to get the child items, and this means that we are getting the child items from this folder. And now let's run our get metadata activity and let's see what happens and what kind of output it will yield. And now our pipeline is running, and now our pipeline has succeeded, and we can check out the outputs of our get metadata activity. As you can see, we have this child items list here where we have 3 objects containing these files. So basically, we would like to filter out our child items based on the condition that the name of the file contains .csv. And that is something that we are going to do next. So let's close this output and then let's add filter activity to this pipeline. And now we want to filter out this get metadata activity output and especially the child items. And this child items is now the array that we are going to filter out. And then to the condition we want to specify the expression that would filter out based on the name. And I have already prepared the expression and it would look like something like this. So basically we are getting that at item that would refer the current item that we are iterating, and then we would get that dot name. If you remember, that item is actually an object, and in that object we have that property called name, and with this dot name reference we can get that. And then we want to check that does it contain .csv, and if it does contain .csv, then it's not going to be filtered out from our list. And now we can click OK, and we can try to run this pipeline and see what happens. Now our pipeline is running, and now it has succeeded, and we can check out the outputs of our filter. And we can see that now we have filtered that list of child items, and we only have those CSV files there. Previously in this series, we have mainly used the lakehouse that is only one of the data stores in Microsoft Fabric. And in this video, we're expanding our scope a bit since we are going to copy some data to data warehouse. That is a preferred data store in Fabric for many people and organizations. But now, without further ado, let's open up Fabric and check out how this is done. Now I have the Fabric open here, and I have opened my lakehouse where I have this folder called Fabric DE Series 19, and in that folder I have this file called movies.csv. And in this file I have just the header and few rows of data. And now we would like to copy this file to our data warehouse. And here we have our data warehouse. We don't really have anything here yet, since this is just a new data warehouse that I recently created. But now we would like to copy this CSV file to that data warehouse. And of course, we can start by creating a new pipeline for this purpose. Let's name our pipeline according to our naming conventions. And then when this loads up, we want to start by adding a just copy data activity to our canvas. So we can select copy data activity from this list. And now we would like to configure this copy data activity to copy that CSV file to that data warehouse. And of course, we're going to start from our source configuration. And to this source configuration, we are going to select our lakehouse. And then we are going to use the file section of our lakehouse since our file is there. And then we are going to point our file path to that file that I just showed to you. And then we have to change the file format to delimited text. And we don't need to touch any of these CSV settings since our file is already following these standard settings that we have here. And we can try to preview the data and see that we have configured everything correctly. And here we can see that our data looks good. So now we have configured everything on the source side. And we have done this already previously in our series multiple times. So this should be some basic stuff. And next we configure our destination. And now we want to select our warehouse. And then we are going to configure this destination to write that CSV data to this warehouse. And since we don't have any tables there yet, or a table for that file specifically, we are going to use this auto create table feature that will actually create the database table for this file. Also, a nice feature in this auto create table is that it will also create the database schema. And if you're not previously familiar what is a database schema, you can basically think about it as this kind of a folder or logical grouping of database items like tables, views, and stored procedures. But yeah, we're going to create a new schema for our table, and that's going to be Fabric DE Series 19, and then our table name is going to be movies. So this will create movies table to this schema. And then we can check out some advanced settings that we have available in this activity. We can start from this pre-copy script that is usually one of the most used advanced settings. Here you could define some SQL statements that are executed before this copy data activity runs. One typical use case here is that you would like to empty the table before loading the data. So you could have here, for example, a truncate table statement that would wipe the table clean before adding the new data. But since we don't have there any tables, or we don't have that table yet, we are not going to define anything to this pre-copy script. But yeah, we have now configured everything on our destination side as well. Then we can check out this mapping tab here that would allow us to do some data mappings, meaning that we could map data from our CSV columns to our database columns. And we can actually click this import schemas button so we get that initial mapping here. This will take a little while to load up. And now it is done loading, and here we can see how our data would map from our CSV file to our database table. Of course, since we don't have that table there yet and we are just using the auto create table feature, the column names in the database will be exactly the same as they are in the header of the CSV file. Of course, here we could do some adjustments to these names if we would like to. For example, write something else to the rating field or whatever we want. Or maybe change some data types here to better fit our data to the correct type. For example, use some numeric values for our rating or year columns. But yeah, these mapping settings are optional, and in some cases you might want to use them, but for now we can delete all of these mappings and we can just go with the defaults. And next we can click this run button and try to run this pipeline and see what happens. Now our pipeline is running, and this will take a little while to complete. And now our pipeline has succeeded. And now we can go and check out our data warehouse. Do we have that table there? And now we can see that we have a new schema here. And in that schema, we have one table called movies, where we just copied that data. And we can see that in that table, we have that same data that we had in the CSV file. So everything went fine, and we managed to copy the data from that CSV file to this data warehouse table. Also, I would like to emphasize that this process of copying this CSV data to this data warehouse table, it's pretty much the same even if you would be using some other data store like Azure Blob Storage or maybe Amazon S3. But now let's talk about running stored procedures in Microsoft Fabric data pipelines. For people not so familiar with stored procedures, a stored procedure is an object in SQL database like data warehouse in Fabric or Azure SQL database or basically any other relational database, since most of them support using stored procedures. Stored procedures contains a pre-written SQL statement that can be saved and executed. It's like a function or a script that performs a specific task such as inserting data, updating records, or retrieving information from a database. Stored procedures are useful because they can encapsulate complex operations and help ensure consistent data processing and improve performance by reducing the amount of data transferred between the database and the application. But now enough talking, and let's open up Fabric and check out how to run stored procedures in data pipelines. Now I have the Fabric open and my data warehouse open here. Here I have a SQL script that I have prepared for today's exercise. And here the script first creates a schema called Fabric DE Series 20, and to that schema we will create a table 1. And in that table 1 we have two columns, column 1 and column 2. Then we create our first stored procedure called stored proc 1. And this stored procedure takes in two parameters, param1 and param2. The first parameter is this kind of a string type, or in database language, a varchar type, and then the second parameter is integer or numeric type. And this stored procedure is a very simple one, and it will basically insert those parameter values as rows to this table 1 that we created. So here is the SQL statement that it will run. So insert into table 1 and select those parameter values that are coming to the stored procedure. And then we have our second stored procedure, And this stored procedure is very similar to the first one, but this doesn't insert any data to the table. It will just basically run this select statement and select those parameter values and also select current timestamp as timestamp here. And I have already ran this script, so we have all of these stored procedures and schemas available here. Here we can see the table 1. We shouldn't have any rows here yet, and then we have the stored procedures here as well. Now we can go back to our script and we can try to run one of the stored procedures. This is the statement that would basically run the stored procedure. So you're referring to the stored procedure and then giving it the parameters that you want. And this is our first stored procedure. Let's run this one and let's see what happens. It will take a little while to run. And after running this stored procedure, we can select all the rows from our table 1 and see that do we have new rows here. And we do have one row in our table. Basically, we just inserted these two values to our table. And if we would run this stored procedure again, we would get another row with those exact same values there. And we can verify that by selecting the data from our table, and now we have two rows there. Next, let's try to run our second stored procedure, but this time let's give it a little different values than we had for our first stored procedure. Let's see what happens. And this stored procedure after run just returns the parameter values and then the timestamp as well, like we have defined in the stored procedure code. And next we would like to utilize these stored procedures in our pipeline, and we can check out how that will happen. So let's create a new data pipeline. And let's name that pipeline according to our naming conventions. And then let's wait for our pipeline to load up. And then we can add just the stored procedure activity to our pipeline. Basically, this stored procedure activity is meant for running stored procedures. And we can talk about a little bit more about this stored procedure activity. And now we can talk a bit more about this stored procedure activity. Let's first open the settings tab of our stored procedure activity, and here we define the connection that will be used for our stored procedure. Now I only see here some Fabric data warehouses that could be used, but also stored procedure supports other SQL databases. And here we can click that more and see what are the currently supported ones. And here we can see that we could, for example, run stored procedures in Azure SQL database or Azure Synapse Analytics SQL DB or one of these other databases here, like on-premises SQL Server database. But yeah, the process is pretty much the same when running stored procedures there, and we are going to use this Fabric data warehouse here because it is the simplest one to use when you're using Fabric. But yeah, let's close this, and then we can just select the Fabric data warehouse that we have been using. Next, from this list, we can select the stored procedure that we want to run. And we can try to run first our stored procedure 1. And after we have selected our stored procedure, we can define the parameter values for our stored procedure. If you remember, it had two parameter values. We could either write those parameters here, or we can click this convenient import button that should import those parameters from the stored procedure to this pipeline. And here we have those parameters that we defined for our stored procedure. And now we could give some random values here. Let's write here pipeline value to our first parameter and then just 333 to our second parameter. And now we could actually try to run this and see what happens. And it has already succeeded. And we can check out, do we have a new row in our table by querying the table 1. And now we can see that we have a new row in our table 1, and those values came from our pipeline. Next, we could try to add a new stored procedure activity to this pipeline by just copying this stored procedure activity. And then we can try to run our second stored procedure using this activity. And let's change the stored procedure to our stored proc 2. And select it from the list. And since our second stored procedure had the same parameters as our first one, we don't need to import new parameters here. Let's write to our first parameter hello, and then to our second we can write 321. And now we can try to run this pipeline and see what happens. Remember, our second stored procedure is not inserting data, it's selecting data, so it should be returning data. But yeah, now we ran those both stored procedures, and now we can go to our data warehouse, and we can check out that we should have another new row in our table 1. Yep, now we have two pipeline value rows with that 333 column 2 value. But what comes to our second stored procedure that we ran there, it was that stored procedure that should just return the data that we are giving it with the timestamp. So maybe we would like to get that data back to our pipeline, but we can check out the output of our stored procedure activity, and we can see that we don't get really any outputs from that. And now I want to talk about some other ways how you can use stored procedures in your pipelines and return the data from the stored procedure to the pipeline itself. Let's start with the script activity. This is another activity that basically runs SQL, and we can select our data warehouse here, and here we could define, for example, a script that we want to run. I'm not going to spend too much time discussing what is a script activity, but basically this is an activity to which you could write some SQL logic that would be then executed. And then you have two options here, query and non-query. And with the query option, you could actually return some data from the SQL script to the pipeline itself, like using the lookup activity. And with the non-query option, you are not really returning anything. And with this query, we can actually run our stored procedure too, that would return some data to our pipeline. And we could, for example, write to our first parameter value from pipeline, and then to our second parameter, we could add just number 1. And now we would be able to run this using this script activity. And we can check out what happens if we now run this pipeline. And now our pipeline has succeeded and we have run all the activities successfully. And now we can check out the output of our script activity. And we can see that we return some data. And here we have this rows array. And in that rows array, we have that data coming from our database or from that stored procedure execution. So we have those parameter values in the param2 and param1 values, and then we have that timestamp also that we have defined in our stored procedure logic. And now we could use this data as dynamic content in the following activities in our pipeline. And now let's talk about yet another way of running stored procedures. And one other way would be using lookup activity. And with this lookup activity, we can select our data warehouse here. And after we select the data warehouse, we get these options to use query table, query, or stored procedure. Of course, we could use this query like with the script activity and define manually the query to run our stored procedure. Or then we could use this stored procedure setting here and select the stored procedure like we did with the stored procedure activity. And also with the lookup activity, we are also able to return some data to our pipeline. And then we have actually yet another way of running stored procedures, and this would be using copy data. When we're using copy data and configuring our destination, we can actually use these advanced settings and define this pre-copy script. And here we can define SQL that is run before the copy activity runs. So basically we could execute some stored procedure logic in this SQL script here. So this is yet another place where we could utilize stored procedures and do some operations in the database before we load the data in. In this video, we're going to use concepts and activities that we have already covered in the previous videos in this series, like lookup and for each activity. With those activities and some dynamic content, we're going to cover the concepts of generic and configurable data pipelines. We have already touched this topic a bit in the previous episodes, but I want to dedicate this video to these configurable and generic data pipelines so that you really understand the concept, since in my opinion this is one of the most essential concepts to understand with data pipelines. But now enough talking, and let's open up Fabric and learn how this concept works in action. Now I have the Fabric open here and I have my Lakehouse open. In this Lakehouse I have created a new folder called Fabric DE Series 21. And in that folder I have 3 subfolders. I have configuration folder, destination folder, and a source folder. Let's start from the source folder. In the source folder, I have 4 txt files. In these files, I just have some random content. Since the content doesn't really matter, since we are going to just use the binary copy in this demo today. And today I would like to copy these files from our source folder to our destination folder. But for this copy operation, we are actually going to build a configurable pipeline. And then we have this configuration folder where we have the configuration for that pipeline that we are going to build. In this first configuration, we have the configuration for our first 2 files, for our file 1 and file 2. And we have the instruction here where to find those files and where to copy them. So we have the source folder property here, and that tells where is the folder for our file. And then we have the source file name, which tells the name of our file. And then we have the destination folder, which tells the destination folder where our file is going. And then we have the destination file name that will be the file name in the destination once we have copied the file. And this first configuration handles those 2 first files. Then we have our second configuration, and here basically we have exactly the same properties that we had in that first configuration, but now we have the configuration for the file 3 and file 4 here. And now let's talk a bit about these file names that I have here. I have that 001 and 002 here in the file names. And in the pipeline logic, we're actually going to use parameters that we're going to give our pipeline to determine which configuration we are going to use when the pipeline runs. This means that we could actually have here way more of these configuration files that would copy different files based on the configuration. But let's keep things simple and let's just use these 2 configuration files today. And now let's start to build our pipeline. Let's go and let's create a new data pipeline, and let's name that pipeline according to our naming conventions. And let's wait for our pipeline canvas to load up. And then what we want to first to do is to look up the configuration. So for that, we're going to need the lookup activity that we have covered in the previous videos in this series. And to this lookup, let's name this lookup a bit differently, and let's name this lookup configuration. And to the connection, we want to configure our lake house that we are going to use. And then we're of course going to use the file section since our configuration is there. And then we are going to point this directory to our configuration. So that will be the Fabric DE Series 21 folder, and under that the configuration folder. Then it will point to this folder that we have here. And next we would create the logic to determine which configuration we are going to use from that folder. And for that we are going to create a pipeline parameter. And let's call this parameter conf ID. And for this conf ID, we don't need to add a default value. And then we can use this conf ID as part of our dynamic expression to determine which files to fetch. And remember, our naming convention for our configuration files is the configuration ID underscore conf.json. So here I'm creating this expression that will concatenate the conf ID to that underscore conf.json string. So this would create the name for our file that we are going to fetch from our configuration folder. So basically, depending on the conf ID parameter, we would use a different file from that folder. And this expression should be okay like this. And next we want to change the file format to JSON since we're using JSON files, and then we want to untap the first row only option. Since with the first row only option we would only return the first configuration from our configuration file, but this time we want the entire configuration, so basically those 2 configurations that we have in the configuration file. And now we could actually try to run this lookup activity and see what happens. Let's run this pipeline to see that we have configured everything correctly, and now we need to input the value for our conf ID. Let's try to fetch our first configuration file. So let's type there 001. And now let's run our pipeline. Now our pipeline has succeeded, and we can check out the outputs of our lookup activity. And here we can see that now we have fetched the configuration to our pipeline. And now we can use this configuration in the following step as dynamic logic. And now we would like to pass this value array to our for each activity and iterate over this list of objects that we have here. And then use these properties in these objects in the dynamic content of our copy activity that will be inside our for each activity to do the copying files from our source folder to our destination folder based on these instructions here. So let's do that. So next, let's add for each activity to this pipeline, and then we can name that a little bit better, and let's name this for each configuration item, and then we can select the items that we want to iterate, and basically that will be the lookup configuration value array. So with this output.value, we will be actually getting that value array that we saw there. Basically, this entire set is the output, and when we want to get this value array, we would refer to that output.value, and this will pass down this array to our for each activity. And next, we can add the copy data activity to our for each activity and then start to configure our copy data. And let's configure the source first, and we want to find our lakehouse here, and then we want to use the file section, and then to configure the file path. And now we're going to use the dynamic content to configure this copy data activity based on the configuration. So we want to use this source folder to be our file path and the source file name to be our file name. And after that, do the same thing for our destination. And if you remember from the for each video in this series, when we want to refer this entire object here, we would use that add item reference. So if we want to get that source folder, we would use that add item .source folder, and then we would get this value as dynamic content. So let's configure our copy data. So first to the directory, we are going to use the item, and then we are going to add dot, and then we're going to use the .source folder, and then to the file name, we are going to again use the add item, and then dot, and then the source file name. And other settings should be all right, since we are going to copy the files in binary format. And now we should be done with our source configuration. Next, let's configure our destination. Again, let's select the lakehouse that we're going to use. And then let's select the file section, and then to the directory. Again, use add item reference and then dot. But now let's use the destination folder, and then to the file name, we're going to use add item, and then we are going to use the destination file name. And again, we don't need to touch any other settings here. So now we have basically configured this correctly as well. And now we are ready to run our pipeline and see what happens. And now we can run our pipeline by clicking this run button here. And then we have to input the value for our conf ID. Let's use the first configuration that we have there. So let's type there 001 and then run our pipeline. And now our pipeline is running, so we need to wait it to succeed. And now our pipeline has succeeded, and we can see that we first run our lookup configuration that returned the configuration from our configuration file, and then we iterated over that configuration and used the values from our configuration as dynamic content in our copy data activities, and copied data from our source folder to our destination folder according to instructions. So with those instructions, we only should have copied those first two files. So we can check out our destination folder. Do we have some files here? Let's refresh that folder, and we have first two files there. Remember, we had 4 files here, but since we only now run with that first configuration, we were only able to copy those first 2 files. But now let's create a new data pipeline, and I'm going to explain to you why quite soon. And to this pipeline, we are going to just add 2 invoke pipeline activities. And let's add another invoke pipeline. And with this, I'm trying to explain to you about the concept of this kind of a generic pipeline. And with these 2 invoke pipeline activities, we could be actually running exactly the same pipeline that we just created. And with the first invoke pipeline activity, we could pass the configuration value of 001, and to the second one, we select exactly the same pipeline, and now we would pass the configuration value of 002. This means that we would actually use the same pipeline as part of another pipeline 2 times, but we would do different operations based on the parameter value, which would then determine which configuration to use for that pipeline. This means that this original pipeline that we created is kind of a generic pipeline that we can instruct based on the configuration, and that configuration is chosen based on the parameter. With this concept, we can use the same pipeline in multiple different pipelines to perform a little bit different tasks. Of course, always the task is to move binary data from place A to B. This means that for these similar operations, we can just create this generic pipeline, and then we don't have to create a new pipeline when we have a different use case that is very similar to one that we had previously. Then we would just have to create a new configuration, and we wouldn't have to touch the pipeline itself at all. And now I want to discuss a little bit more about these configuration files and why I'm using these JSON files instead of database tables like some other people do. In my opinion, using configuration files is the way to go, because using this JSON format allows you to do way more things than using database tables, because these support more complex data types like arrays that you can have as part of your configuration. Also, another point is version control. When doing things professionally, you would like to have these configuration files in your version control, and then just use some DevOps pipelines or some release pipelines to deploy these configuration files from one environment to another. And using database tables, using that version control is not so straightforward as using files. So that's why I would rather use files than data in a database table. Also, one key thing to consider is also the naming conventions for your configuration files and what kind of logic you want to have when using those generic pipelines to determine which configuration file to use. But yeah, these are some things that you can figure out on your own in your own environment and come up with the system that works for you. But now let's open up Fabric and talk about data mappings and how to do them dynamically in data pipelines. Now I have my lakehouse open. In this lakehouse I have created a new folder called Fabric DE Series 22, and under that I have 2 subfolders, configuration and source. In the configuration folder we have the configuration file that we're going to use in this exercise, but we're going to come back to this configuration file shortly. In the source folder I have 2 CSV files, animals.csv and movies.csv. In these files I have just a few rows of data and a header. And we can check out the movies files also. There's a film year rating and then a few rows of data. Then I have this data pipeline that is already pointing to that movies.csv file there and trying to copy that to a lakehouse table called movies. As you already probably know, in the copy data activity, we have this mapping section here. And in this mapping section, we can define the mapping from the CSV file columns to the lakehouse table columns. And we can automatically import schemas by clicking this import schemas button here. This will take a little while and import our columns from the CSV file and our columns from the lakehouse table. And here we have the mappings that the data pipeline automatically created for us. Good thing to note here that I don't actually have this movies table in my lakehouse, and if we would run this pipeline would automatically create that table and use the default mappings for that table. And the default mappings for that table would be to use the column names from the CSV file to be the column names in that lakehouse table. And we could actually use this mapping feature here to do some changes to the columns. For example, change the column names. For example, type here movie instead of film. And also we could be changing these data types to something else, because in CSV file everything is string, so it's mapping everything as string to the lakehouse table as well. But we have some other than string data in our CSV file, and we would most likely want them to have something else as string. This mapping feature here is very useful, but what if we have like 100 CSV files and we would like to use some iterative logic and a for each loop, and in that for each loop just one copy activity to handle all those files? Of course, then we couldn't have a mapping feature there if the CSV files have different columns in them, so we wouldn't be able to do these changes here. But we can delete these mappings here, and we have option to use dynamic content in this mapping. which means that we could do this mapping actually dynamically. Let's import these mappings back here so I can explain to you how that would happen. Now the mappings are back, and we could actually go to this View tab and edit the JSON code. Here we can see the pipeline JSON code, because on the background this pipeline is defined as this JSON here. And here we can find all the mappings that we have defined under this translator object and mappings here. And here we have exactly the same mappings that we have in the UI. So basically, if we would use the dynamic content, this mapping feature would expect to have this kind of object. So we would have to replace this object with something that comes out from the configuration files. And in the configuration files have this mapping configuration for our files. Now let's go back to our lakehouse and check out the configuration file that we have here. I have already prepared the configuration for these two files that we have here. For example, we have the source folder, source file name, destination table schema, and destination table name for each file that we have there. And then we have also this mapping section here that we would use dynamically to replace the mapping when we use that iterative logic in our pipeline. In this mapping for the movies file, I have made some slight changes. For example, the column name 1, I have changed the film name to movie when we copy it to the lakehouse table. I have also done some data type changes here as well. For example, for the column year, I have changed the data type that is coming from the CSV, that is string, to integer when it's going to the lakehouse table. Also, I have done a data type change for the rating as well, and there I'm changing that string to float value. For the other file, the animals.csv, I have not done any changes to the mapping, so we keep that as it is. Next, we would like to build a pipeline that uses this configuration file to copy those two files from our source folder to our lakehouse tables. Let's start building. So let's hit create, and then we want to create a new data pipeline. And let's name that data pipeline according to our naming conventions. And let's wait to the canvas to load up. And then we want to add the lookup activity first, that we are going to use to look up the configuration files. And let's name this lookup a bit better here. Let's name it to lookup conf. And then we're going to select the connection that will be our lakehouse. And then we are going to untap the first row only option since we want the entire configuration files. Then we are going to use the file section. And then we are going to point this lookup activity to our configuration file like this. And then we're going to change the file format to JSON. And now this lookup would be ready to fetch our configuration file. And we can test this out and click run. And let's see what happens. Now our pipeline has succeeded, and we can check out the output of this lookup activity. And we can see that we have the configuration contents here now in the pipeline. So we could pass this value array here to our for each loop and loop through this configuration and use these properties in the copy data activity inside that for each to do the copy activities. Let's close this configuration, and then let's add our for each activity to this pipeline. And let's name this bit better as well. Let's name it for each conf. And then we would like to configure the items that we are going to loop through. And that is going to be the value array that is coming from the lookup activity that we have available there. And then we're going to hit OK. And then we're going to add a copy data activity to inside this for each activity. And let's name this copy data a bit better as well. Copy data from lakehouse CSV file to lakehouse table. And then we are going to select our lakehouse to be our source. And for this, we want to select the file section. And now we would like to configure this dynamically using that configuration that we are looping through here. So our directory is going to be our source folder from our configuration, and then our file name is going to be the source file name from our configuration. And then the file format is going to be the delimited text. And to these delimited text settings, we don't need to touch since those files are using these default settings already. And now we should have configured our source already. And then we're going to configure our destination based on our configuration. And now we are going to use actually the table section. And then we are going to add dynamic content to our schema name. First, it's going to be the destination table schema. And then our table name is going to be destination table name. And then we are going to change our table action to overwrite, so that we will overwrite always the data that is in the table. Then to the mapping section, we want to add some dynamic content. So basically to the mapping section, we want to refer to this property in our configuration file. So our mapping section would be replaced with this object here that the mapping is waiting to have. And this would then do that mapping dynamically based on our configuration. And now let's go back to our pipeline, and then we want to add dynamic content to this mapping section here and refer to that mapping there by using that item reference that we already did before. And now we're done with the configuration. We can hit this validate button to see that we have configured everything correctly in this pipeline. And we can see that our pipeline has been validated and no errors were found. Let's click this run button here to run our pipeline. That will actually save and run our pipeline. And now our pipeline is running. And now our pipeline has succeeded. And we can see that we ran that copy activity 2 times, since we had 2 configurations in our configuration file. And next we can go to the lakehouse and see that we have some tables here. Let's refresh this table section here. And here we can see a new schema, and under that schema we should have 2 tables. Yes, we have animals and movies. We can check out, for example, the movies table and see that we have that column name change there and those data type changes there that we defined in that configuration mapping. And here we have our lakehouse table. And here we can see that our first column is called movie and not file, since we changed that in the configuration. Also, our year is now data type integer and our rating is data type float, that we also changed in our configuration. Now you have reached the end of this data pipeline masterclass. If you went through all the tutorials, you should be already very capable of using this tool. If you'd like to learn more about Microsoft Fabric and maybe start mastering notebooks next, check out my YouTube channel where I have other videos on notebooks and many other Microsoft Fabric data engineering tools. Now I thank you for watching and see you in the next video.